Oh, hello, lovely people. Welcome. I'm Piatato. I don't know why I always mess up your name, but hello. Hello, Nell. Hello, Dimdia. Yeah, Mas. Oh, I'm gonna Mashu Doku. I don't know if we're gonna get to that today, but it's definitely in the queue somewhere. Uh, anyways, so small announcement today. Uh, Shout out to Directionary. Oh, yes, I should do this. Shout out to Directionary for buying me a coffee on Ko-Fi. That's just giving some amount of donation money to me on Ko-Fi. You can find Ko-Fi link in the description below, and my Patreon down there too. Ko-Fi is better for like one-time donation sort of thing if you don't want like a monthly sort of subscription dealio. But you could also do a monthly on Ko-Fi too. I don't think anyone's monthly on there, but yeah, Patreon is usually more for that. But Ko-Fi also, the creator gets all the money you send. So if you have concerns about corporate greed and stuff like that, then you know, I guess Ko-Fi is for you. Anyways, moving on from that. Hi, Gum Hippo and Lakia and David. Welcome everyone. Like has been activated. Yes, please like the stream. If you like the stream, of course. If you don't like the stream, I would say dislike the stream, but apparently that doesn't do anything anymore. So I think you'd be wasting your energy to dislike the stream. You should probably just like it instead, because maybe like to dislike. But why would you dislike the stream? There's nothing to dislike. Um, I don't know why I'm encouraging people to dislike the stream. Thanks for showing up early, by the way, everyone. Hello, Rockrat. Okay, let's do. I'm thinking we'll do the what was it? What is this called? It's right there. No solutions puzzles. Prove there's no solution to this puzzle. I think we'll do those sort of in order, and then definitely nothing to dislike. We'll do those in order from like how I have them in the description, and for the actual puzzles themselves, we'll go ahead and have you guys vote on which one we do next. I have like sets of three, so I'll switch up the sets of three, and then we can get some variety in there. Anyways, so let's start with a couple no solutions puzzles. So in case you have not seen a no solutions puzzle before, this is basically a puzzle which doesn't have any solutions, and our job is to prove to ourselves, basically, that there is no solution to the puzzle, which seems counterintuitive, but it's very interesting and a good exercise, especially for setters, to look at something like this and say, oh, I understand why that doesn't have any solution. It gives you a lot of intuition for future things. Now, Turganis has given us this thermometer irregular Sudoku. So irregular Sudoku is the same as normal Sudoku, except that the regions are just differently shaped. So in this case, it's 1 to 6, and you just put 1 to 6 in each row, column, box. But we're not going to be doing that anyway, because we need to we need to figure out why we can't do that. Hi Chameleon. Hi Turganis. Hi Jim. Hi Super Rabbit, and hi Zombie Hunter. Was anything you put on the LMD? I hope not, Zombie Hunter. That's a no solve puzzle. Oh, right. Hopefully, if you have any suggestions for your puzzles, Zombie Hunter, feel free to put them in the submissions channel in my Discord, and I'd be happy to do them, and then we'll get at least one solve on them. All right, so I usually don't show the whole process of me figuring out why things have no solutions. I usually just show in the pre-recorded no solutions just the final result and sort of the best way to explain it. Yeah, don't forget to like the video. Also, hello FB Jefferson and Andrew Sakis. You're here as well. All right. So it might be interesting to see me trying to figure out why this has no solution. So obviously it probably has something to do with irregular Sudoku, because it's an irregular, and these thermometer shapes. So we're probably going to have to do some leftover boys. So this boy right here, in this in these 3 columns, this boy is the odd one out. Well, I guess in these 2 columns, this boy is the odd one out, and this boy is the odd one in. So this digit, whatever it is, has to appear somewhere in this column. But it also appears in this region as well. So it can't be in any of these cells, so it has to be up here in that region. So then in this column, it has to be right there. So these are the same cells. There's lots of ways you can phrase that, as in these are 2 sets of the digits 1 to 9, or not 1 to 9, I hope not, 1 to 6, and then you remove this set of digits 1 to 6. 1 to 9 is so easy to say, and 1 to 6 is so hard to say. And then we add this one in to balance it, I guess. So those are the same digit, which is probably important. We can say the same thing about these 2 digits. And is that interesting? All the 9 digits between 1 and 2. Hello, Isabella. Welcome. Is that interesting? Well, maybe we can... Is there more going on in the rows? So I can see that this sort of sticks out, but there's a lot more sticking in there. This is important. So these are the same digit as well, and surely there's another set of those. Yeah, there is. All right, so I guess we need to ask, well, there's a digit between these 2 in both cases. Doesn't have to be the same digit, of course. I guess this can't be red, so red would go there, because red and blue can't be the same digit. I guess maybe we can ask the same question about blue in this region. Blue goes there. And then blue in column 6 is a good question from Jim. Well, blue cannot be yellow. Well, I guess we can ask blue in this region. Where does it go? It can't be there, so it has to be here, which means that blue has nowhere to go in this region. Because, yeah, it has nowhere to go. Is there an easier way to see this? I feel like this is definitely something that I would do a few times and sort of think, like, is there a better way to see this? Because that felt a little bit messy. I mean, I guess we really don't need to color these. Or do we? I guess we kind of need to color the yellow, right? Because we need to know where blue is in this region. Felt a little bit messy, but I'm not like 100% confident that that's the easiest way that it breaks, you know? I'm sort of like waiting for someone to say, no, you're stupid, there's a way easier way. Green is blue? Well, they're in the same row, so that's definitely broken then. Yeah, I'm not sure. We might come back to this. No, that wasn't the initial assumption for the blues. Uh, there was no initial assumption for the blues, just that blue had to go in this region, and the leftovers said that blue is these 2 cells. So then blue goes here in this region, and then yellow goes here and here in these regions because of leftovers again. Or wait. Do we know that? Actually, these are not determined in their order. But still, this cannot go there because of the leftovers. Okay, that's a little bit cleaner, I guess. I don't know why not coloring these individually made it cleaner for me for some reason, but if you just look at red starting in row 1, column 4 that breaks by itself. Red in column 2. Oh, that's also a thing. I guess blue in column 2 is probably the same. Yeah, that's the same idea. Okay, so we don't need to look at blue. We don't need to look at blue in this region, and we don't need to look at blue in this region. All we need to do is look at blue in column, not column 2, column 5. Okay, that is much easier. Definitely. All right. I feel like this one has been conquered now. It's always so awkward to end a no solutions because you're like, I think I've proved that, but is that the idea? I mean, red in column 2 is the same as blue in column 5. It's symmetrical. Okay, you saw it as columns. Okay, because like presumably that's like the only thing that breaks about the puzzle is not necessarily going to be the thing that the person had designed for it to break, right? This is an arrow no solutions by the Sonic person, or sometimes known as Potato Head, Potato Head 12, Potato Head 21, something like that. Yes. Bowls versus tips columns. Okay. We have confirmation from Turgenis that this is what he he wanted. Okay, so we have arrows. So the digits on the arrow sum to that circle. So if this was like a 1, 4, this would add up to 5. And all the arrows coming off that have to sum to that same digit. So let's see here. We have these two are the same number, which goes down here, obviously. We could give those a color if we want to. Even give this a little flash to indicate that it's down there, but corner marked. Which I guess somehow relates to. So this is really suspicious. This arrow existing here is suspicious to me because if this had to do with like the sum of these digits, which it probably does have to do, but still, if this had to do with something like the sum of these digits, then you would be thinking, why is this here? Well, I think this is telegraphing to me that it has to do with like the number of digits that we can use. So I guess we should be thinking about how many digits can we repeat in this little area, because we can't repeat more than 3, because if we had 1, 2, 3, 4, if this was a 5, for example, and then we had I just set that up just randomly, but it worked anyway. Well, this isn't going to work anyway because these can't repeat there, but just for the sake of argument, just play with me for a second, roll with me. Then this is 4 digits that repeat, so then we would have to put 1, 2, 3, 4 down here, and that's not going to work because there's only 3 cells down there. So we need at least 1 digit which is different between these two, but then we're also going to need 2 digits which is different, because this is obviously like if we only had 1 digit which is different, then it's not going to add up to the right sum. One of the arrows isn't. Can you have 4 sums for the arrows have to be 8 unique digits? 8 unique digits. Interesting. You're saying they can't have any repeats in them. Let's think about that. Okay, so if this is a 9, oh. Yes. I was looking at chat and then I looked back at the puzzle and I'm like, "Oh, I see now why there can't be any repeated digits." So let's just go with this example for now, and then we'll see why there can't be any repeated digits. So if there was just say 1 repeated digit, right? If we want to put a 1 here and a 1 here, then, well, what are these 2 digits? They have to be the exact same digit, because 9 minus whatever this is going to be the same digit. These will both have to be 8. So no matter what you try to repeat, if you repeat one of these 2 down here, that digit which is here or here, will have to go up here, and that's not going to work. So we can't repeat any digits here, which means that these are 8 unique digits. But this digit has to be greater than all of these digits, which are on the arrows. So in this set of cells, we have 9 unique digits. But this is a digit which sees all of these cells. But that can't be the case because we have 9 unique digits. This would be the 10th digit. And as far as we know, that does not work. That's cute. Okay, fun. Let's do one more, and then we'll go for a regular puzzle. I'm having fun with these. Scorp 17, yeah. I'm Scorp 17. Yeah, so it's 0, obviously. Okay, so this is by Zeta Math, and it's a little killer. I can't remember. Does Zeta Math hate little killer? I can't remember. So we have 3 cells here which are on, well, little killer is that the indicated diagonals sum to the given total. So these 2 cells sum to 5, these 3 cells sum to 6, these 4 cells sum to 11. And they can repeat if they want to. These 3 cells sum to 6, but these 2 cells sum to 5. That seems extremely suspicious because, for example, if this was a, well, obviously this has to have a 1 in it, because if it didn't have a 1, then it would be 222 at least, and these are in the same box, so that does not work. So this cell can't be a 1 for sure. But obviously we could repeat, say, 1s in these cells. Interestingly, we can't repeat 2s, and we can't repeat 3s, because then we would have to put a 0 here, and the 2 would require a double 2 in the box. So if we're going to repeat a digit, we can only repeat the 1, which requires this to be a 4. 6 diagonal in 3 cells is kind of interesting. Never thought about that. Yeah, obviously 1, 2, 3 is an option, but also double 1, 4 is the only other option. So then, if this is double 1, 4, we're obviously going for a 2, 3 here. And if this is triple 1, then we can do a 1, 4, but only this way, because this cell is always going to see a 1 either here or in these 2 cells. So now the question is, why does this 11 break when this is the case? Well, this is a 1, 2, 3, 4 triple, or 1, 2, 3, 4 quadruple. So these are a 5 and 6. So this is at least a 5, which means that these 3 cells have to sum to at most 6, which means they also have a 1 in them. Right? I mean, I guess we could also mark them as 1, 2, 3, 4. And this one can't be a 4. Trying to see what's wrong with that now. Hello, Niverio. I think I've missed something in chat. We're talking about war now? Oh, because of the puzzle called War. Got you. Okay, that makes more sense. So the question is, so there's a 1 in these cells, because we can't, again, do triple 2. I don't know why, for some reason, my brain thought that these are the only 2 cells that could repeat. Obviously, these 2 could repeat, and this could be a 4. What is wrong with me? Row 3, column 1 equals 1 by math. I don't know about that, but I know this digit goes down here by Sudoku. Is it possible to not put a 1 in this box? I mean, if we do a 1 here, then that's a 1. I mean, obviously not possible to not put a 1 in this box. I mean, in these 3 cells. Uh, row 3, column 1, obviously. Yeah, okay. 4 unique cells in box 1. Yeah, 4 unique cells in box 1. Oh, okay, so 4 unique cells in box 1. Right, duh, by math. So these cells, we know, sum to 10 because it's 1, 2, 3, and 4, meaning that this cell, which is outside of these two this box, but inside these two diagonals, which sum to 11 together, must be a 1, therefore. So therefore, there's no 1 over there, which means that this is a 1, which means that this is a 1, which means that this has to be a 4. Once we get back to, like, why this is broken here, we're going to figure out a nice way to say this, because, well, now we can't do 4s here. Oh, and now there's no place for 4 in this box. And we can't do 4s here because then we'd have to double the 1, but the 1 is already in the box. So I think what we're getting at here is that you can never put a 5 or 6 on these 5 or 6 diagonals. So these are always 1, 2, 3, and 4. But that makes this a 5 or 6, which means that this is also a 6 sum, which means that you can also never put a 5 on that part of the diagonal. And we, again, can see that this goes here. This seems a little bit too complicated already, but the point being that there's not enough 1s to fulfill the 4s, I think, is the point. Like, you can't fit enough 4s. You can't fit enough 1s to offset the 4s or something. Maybe the sums don't work out. Let's see here. So these are obviously 10. These sum to a minimum of 6 plus another 1. So that's 17. 17 plus 5 is 22 exactly. So you need to minimize it. Yeah, that's exactly the answer. Let's do that one more time, just to be clear. So this is 10 plus the minimum here would be 1, 2, 3, which is 6. So that's 16. 17 with a 1 here. Plus a 5 is 22. These are 11 plus 11. That's 22. So the minimum is the exact. Therefore, this has to be minimized exactly. Meaning that this is all true. But then we have a problem with 4 or something. Oh, it's the Glipperall thing? Oh, right. Of course, this is always a 1. I was trying to sort of do it without the math part. Well, I guess we did the math part anyway. Which means that this is always a 1, and then the 4 has no place. Okay. I think this is just complicated. It's always complicated with little killers. What is the little killer thing? Or sorry, what is the Glipperall thing in the context of this puzzle? If it's helpful. If it will help me explain this easier. Oh, okay, minimizing within each box. Okay, that's okay. I think I'm sufficient with how we've proved this so far. I feel like we sufficiently proved it. I'm feeling more rigorous on this one, particularly because it's by Zeta Math. I feel like I need to do his puzzle justice. because he would want a rigorous proof. All right. Well, that's enough. That's enough of the no solutions for now. So we'll switch over to a regular puzzle, and I will get you guys to pick the first one. So we will head over to the puzzle pick area, and we have 3 puzzles here from which you can pick. I will put up a poll here. Which puzzle next? 1, 2, or 3? I know it's 178. I just didn't know exactly what he was referring to in terms of it. I thought it might be an easier way to explain it. I haven't watched the Simon video, but I have taken a look at the puzzle. I'm not sure if Simon explained it in some very easy to understand way that would have been helpful for explaining it. Yeah, we have a lot of 3 out of 5 estimates today. Well, even though Micro can't in good conscience vote for the first hidden skyscraper, it looks like it's currently winning right now with 53% of the votes. All right, I'll wait just a second more, and then we will call it, and probably end up doing this first hidden skyscraper, which will be good because it's been on the queue for a little while now. Okay, yeah, it's only getting more in favor of Nell's puzzle. So let's go ahead and bring up Nell's puzzle here. Alrighty then. Hopefully Nell changes your mind, Micro. I feel weirdly that like I've done this specific puzzle before, but I definitely have not, and I double checked that. I don't know why it felt like I did this before, but maybe I have. Okay, so normal Sudoku rules apply within the central 9x9 area. Cages sum to the number in the corner. Digits cannot repeat in a cage, even if the cage extends outside the main 9x9 area. Each number in the 9x9 represents the height of a building. The taller and taller buildings block the view of smaller buildings. So that's just saying if this was, say, a 4, and we had maybe a 5 here, and then a 7, 8, 9, we could have like 1, 4, 3, 6, and 2 here, but these cells are the seen skyscrapers, and that's what this 4 is saying in terms of normal skyscraper clues. However, unlike normal skyscraper rules, outside the 9x9 grid, digits outside the 9x9 grid, I was like, what? Digits outside the 9x9 grid indicate the first building that cannot be seen when looking from that direction at the indicated row or column. For example, if the row were 2, 3, 4, 1, 7, 5, 9, 8, and 6, the clue on the left side, this side, would be a 1, as that is the first skyscraper not seen. So these skyscrapers are all seen, and this one is the first one not seen, because this is lower than this, is lower than this, but this is not lower than, or sorry, is not higher than this. So this one is hidden behind the 4. If it was a 4 of height, if it was a skyscraper of height 4, essentially. And then this one would be 5 because we can see the 6, we can see the 8, we can see the 9, but we cannot see the 5 from this direction. Alrighty then. Hopefully that hopefully that is clear. Yes, I do know it's the first hidden, but I was just explaining regular skyscraper clues because that might be helpful in the context. Okay, so first thing I'm noticing is that there is a 1 in the 8 cage. And that 12 cage has a 1 and a 2 in it. These 15s obviously have to be from 6, 7, 8, and 9. They're either going to be 6, 9, or 7, 8. 26 in 4 cells. That seems kind of interesting, huh? Well, actually, the 15s are... Oh, yeah, the 15s are quite interesting, right? Because that's the first skyscraper not seen, but they're very high digits, right? So, and like this can't be, if this is a 6, this is not going to be a 6 because we can't see the first. Yeah, there's no way that's going to happen. That's just nonsense. Because somewhere there's going to be a 9 and there's going to be a digit on the other side of the 9 that you can't see, and it can't be 6 on both, right? On both ways. So, and the 9, the 9 can never be the first hidden skyscraper ever. Yeah, okay. I just looked at the chat and Micro has the right idea. Hello, Panthera. Welcome. If you guys haven't checked out Panthera's interview from last week, I want to say, then you should go check that out. So after you obviously like the stream and watch the whole stream and participate in the chat, then go watch that stream afterwards. So 9 can never be in one of these cells, because if this was a 9, then the 9 would have to hide behind something. It's the first hidden skyscraper. So there's no 10s in the grid, so the 9 can't hide behind anything, which is quite interesting. Okay, so, and again, we really can't have like double 7 or double 8. That's just not going to work. I mean, it might work in very specific cases, like you could do this, for example, which that doesn't even work. Well, the 8 for sure does not work for double 8. The 7, well, if the here's the thing, the 7 would work if you did that sort of thing, right? 7 and then 1, 2, 3, 4, 5, 6, 8, 7, right? But then you have the 8s here, which are not going to work because there's only one digit which is greater than 8. So you can only hide it from one direction. So we can't do that. This is, for some reason, Penpo is saying this is one step. Okay. Well, I guess we're going to have to get rid of those 6s by hand then. Making my life so hard. Okay, so the 7 is the first one hidden from one direction, and the 8 is the first one hidden from the other direction. But that's actually also hard, because let's just consider that. So 7 and 8, right? So I want to hide the 7 from this direction. So I need a digit greater than 7 to go before the 7. Well, there's only 2 digits greater than 7. There's 8 and there's 9. But if the 8, we're also needing to clue from this direction. So it's really difficult to do that. And the 8, there's only one way it can be hidden, is behind the 9. And it has to be directly behind the 9 because it needs to be the first skyscraper hidden. So we couldn't even do something like this. 9, 7, 8. That's not going to work. Because if we do that, then the 8 is not the first skyscraper hidden from this direction, it's the 7. But now the 8 is hiding the 7, which is what we needed. Wait, how are we going to do this at all? Oh, okay. This is how we're going to do this. We're going to hide the 7 with the 9. Oh, is this stream stuttering? All of my stats are like perfect right now for some reason. Huh. That's weird. This is the one time where it's lagging where I don't know why it's lagging or it doesn't appear that it is lagging. Most of the time it looks like it's lagging, but it's actually not lagging that much. Okay, weird. Like no bytes dropped in so long. Okay. Okay, so let's think about this again. So right, we're gonna have to hide. It's gonna have to go exactly like this: 7, 9, 8, because we've established that we can't use the 9 to hide the 8. Well, we can use the 9 to hide the 8, but we can't use the 9 to hide the 8 if the 7. Sorry, that was the other way around. We can't use the 8 to hide the 7, because if we use the 8 to hide the 7, then the 7 will be hidden by the 9, and it won't be the 8 first seen from this direction. So what we need to do is we need to hide both the 8 and the 9. Sorry, we need to hide both the 7 and the 8 with the 9. So it needs to be something like 7, 9, 8. Now we don't know what order these are in. And then, but then from this direction, these need to be increasing. Like we can't do 2, 1, 3 or something. Because then this will be the first, or sorry. Yeah, this will be the first one hidden. I did that in like the wrong order, but it's actually, it works fine. In my head, I was trying to do something else. This should be a 1 then. So we definitely need to have a 1 in one of these two cells. We don't even know the order of the 7, 8, but both of these need to be 1s, because if the 1 appears anywhere else in those columns, not Q1, if the 1 appears anywhere else in these columns, then that will be the first one hidden. So all of these cannot be 1s. That one can't even be a 1 because the 1 in this box. So this is a 1. There's a 1 in one of these two. Now let's consider, can either of these be 2s? Wait a second. I'm not actually sure that's true. That actually might not be true. There's a slight problem. What if this was a 7 or an 8? Wait, would this one, no, but then this has to be a 1. And then where does the 1 go in this column? Well, it has to go there. Okay, so I think that's still true. The link to the puzzle is in the description. There are many links, but the link is in the description. I can also throw it in the chat as well. Yeah, let me throw it in the chat as well. Okay. Saved. Okay, I think this is true that there has to be ones in front of these. Because like the one in this column has to go at the beginning, otherwise it is hidden. I think that is true. So now we can do the exact same thing we had before. And now I think we can still ask the question, can these be twos? Because if that is a two, then whatever comes here, doesn't matter what it is. It could be a 3, it could be a 7 or an 8. But whatever it is, it's going to block the 2 from this direction. And we can't fit our 7, 8, 9 here. So the 2 cannot go there, because then it would be the first one not seen. Because we can't fit a 7, 8, 9 here. These cannot be 2s. This is going to be a 1, 2 pair. Yes, Kanti made a no solutions Japanese sum, which I'm not sure if we'll get to today, but hopefully. Okay, so this is 3425, which is quite interesting for this cell. In fact, this 10 clue is screaming at me right now, because this one seems like it's going to be the hidden. But it can't be. That is so cool. See if you can work out for yourself why this one cannot be the hidden. Because if it was the hidden, we would have to do this because of the 10 clue. The 10 cage, it has to sum to 10. But now, is 1 going to be the first skyscraper hidden? No, because it's going to be this one. Whatever the heck this is, it could be any digit. It's going to be the one that's the first one hidden. Because the 9 is bigger than everything. That's really cool. So it can't be 1, 9. Therefore, this digit is still going to be the same as that digit. And it has to be the one that's hidden. So this has to be lower. This has to be lower than this in the total, because it's going to be hidden by this. And it can't be something over here because the 1 is already going to be the first hidden no matter what we're doing, right? If this one isn't the first hidden, then the 1 is. There's no other way. And we can't have the 1 being the first hidden. So then this has to be 2, 3, or 4. And this will be, I guess, 6, 7, or 8. So we're getting, if this was a 3, 4, this would be a 2, 3, 4 triple. But we don't know that for sure. What is the add gameter move? A gadmeter? Oh, okay. So these sum to 3, so these have to sum to 9. So they could either be 3, 6, or 4, 5, of course. And I think those all work, right? Because like 1, 2, 3 would work, right? But then this was 3, 6. This would be, that to be 4, 5, 6, right? Oh, that's brilliant, actually. These 6 digits are not 9, 7, and 8. Because if they were 9, 7, or 8, then you'd have to fit a 9, 7, 8 triple in there. Because we know that it goes 9, 7, and 8 in a row together. So then these 3 have to be 9, 7, and 8. And we have to have a 6 in here because we have the digits 1 through 6, and it has to go in order from lowest to greatest until we get to the 7, 8, 9. Right, roped moment. We definitely have roping for sure with this 7, 8, 9. That's whack. So this is a 3, 6 though, is the point. Because if it was a 4 or 5, then we'd have to fit a 6 down here, and that's not going to work. So we have a... Wait, we don't know if this is 1, 2... Yeah, okay, so... Oh no, we do know it's 1... We don't know that the 2 is in here. Because if the 2 wasn't in here, then we couldn't go 1, 2, 3. And we'd have to do 1, 4, 5, and then 3, which is not going to work. So then this is going to be a 1, 4 pair, and this is going to be a 2, 5 pair. Beautiful, beautiful, beautiful. And now we know that it goes 1, 2, 3, 7, 8, 9, 4, 5, 6. So we know there's some kind of roping going on. Same at the top of column 5. Right, this is less than 7, 8, or 9. So these also have to be less than 7, 8, or 9. Right, okay, so this is 1, 2, 3. This is 2, 3, 4. And this can't be a 2. So, oh, but could this be a 3? Yes, it could. Because this could be 4, 5, 6. Yeah. Oh, but wait. We know that this is either 1, 2, 3, or it's 4, 5, 6. And since it has a 1, 2, 3 in it, it has to be 1, 2, 3. Oh, that's beautiful. That's freaking awesome. Oh, well, I guess these are obviously 7, 8, 9. That's so obvious. I don't know why I didn't see that before. Thanks, guys. And the 9 has to go in the middle, right? Okay, Playmaker was saying, what's the high digit in the middle, though? And then I read that as, well, obviously the middle is going to be 7, 8, 9, but that's not what you meant at all. You meant that the 9 is going to be in the middle, which I now understand. Okay, so this is going to be a 4, and this is going to be a 2, which means this is a 2, and this is an 8, which means this is a 7 and an 8, and we have the 7 and the 8 fixed in the order. Wow, this is a cool puzzle. Now this is going to be a 7, this is going to be an 8. We don't know the order of this one. Not in box 8 necessarily, though. Wait, what? Oh, right. I just said, just out loud, before I read that we don't know the order of this one, and then you're pointing out that I had filled in the order of it. Duh. Because there's no clues telling me the order of this, so. Now we know that this is the 4, 5, 6. This is the 3, 2, 1. This will be a 3, 2, 1, and this will be a 4, 5, 6. Be a 5, 6 here. This needs to increase in order, so this is 4, 5, and 6. And again, we do not know the order of this column because we don't have clues on the outside. Yeah, this is brilliant, no? I'm so glad we kept this in the queue. Well worth the wait. Well, this 8 is definitely hiding the 1 here. But we don't know if that's going to be the first skyscraper scene, or first skyscraper hidden, or if it's something else. So now we probably have to branch out a little bit. Oh, we know that this is a 2 and this is a 1 from this 2 here. So there's a 2 down here. That seems suspicious. Because that can't be a 2 because this would have to be double 9, but then the 9 wouldn't be a hidden skyscraper. Double 9 to make 18 is the only way. Obviously, you can't make it with 2 regular digits. The 1 can't be... Oh, the 2 is up here, so we actually get that this is a 2. Don't know how I didn't see that. There's a 2 over here now. Can the 2 go in the 17 cage, or is that even more likely than probable? Yeah, it's probably in the 17 cage. The light away a little bit. Hurting my eyes. But you can still see my face all right. Yeah, I think so. Oh, eyes are watering. I should have done that earlier. Okay, 26 in 4 cells. 26 in 4 cells. Is that super restricted? I mean, 30 in 4 cells is maximum, right? So 26 is 4 degrees of freedom off of that. So it is pretty high. Can you do it without a 9? Isn't that exactly 11 plus 18 plus another 8 is exactly 26. Yeah, so you could do that. Could you do that? Does 8 work in this cage at all? Oh, you could even repeat digits, couldn't you? No, you can't repeat digits in cages, right? Okay. So my thing about the double 9 here is easier than the whole skyscraper thing. um, so if we want, oh wait, we can't put a 9 out here for sure. Right, okay. So if there is a 9 in this cage, it's definitely in these two cells. And we can't repeat digits in the cage. So could this be a 9? Well, if this was a 9, then aren't these two digits the same? Because this is the first skyscraper hidden. So that will be the same digit, which we can't do because we can't repeat digits in the cage. So if there is a 9 in this cage, it is right here. Which will mean that this digit is the same digit as that. Okay, now let's think about 8. So obviously the 8 can't go in these two cells. The 8 is not the first skyscraper hidden in this row. That's pretty clear. But the 8 could be the first the first skyscraper hidden in this row if this was some digit and this was a 9. But this is a 9, so that's not true. So there's no 8 in this cage, which means that it can't be 5, 6, 7, 8. So therefore, it must have a 9 in it. And that 9, again, can't go in either of these two cells because it can't be hidden, and it can't go in that cell because that would make this one and this one the same digit. So this must be the 9. So what do we know with that? Okay, so these still need to be pretty high, right? So 26 minus 9 is obviously 17. 17? 17 without an 8 or a 9 in 3 cells. That seems a little bit restricted, right? For some reason, my brain just cannot understand the difference between +9 and -9, and I always get it screwed up for some unknown reason. I should stop trying to memorize and just understand that 9. Yeah. So what's 7 plus 6 plus 5? 11, 18. So we have maximum 18 and we need a minimum of 17. Well, we need exactly 17. So we can only reduce the 5 to a 4. And we can't do anything else. That's literally, it's only one possibility. It's this. That's all it is. Yeah, it does have to be exactly 4, 6, 7 because we can't have an 8, we can't have a 9. 5, 6, 7 is 18, and reducing that by 1 is, there's only one way to do it. So I don't know why I put the 5 there. So this digit is that digit. Obviously, there's a 3 in here. There's going to be a 3 up here. Maybe we can mark that. Oh, I guess that's pretty obvious from this row. I guess there's a 3 and 2 and whatever digit is not in here, I guess. Hmm. So 3, 2, 4, 5, or yeah, 4, 5, 6, or 7. Not super useful, I guess. 5 in box 3. Oh, that's helpful. So then there's a 5. Well, we can just clue these, right? Or clue them. We can just fill these in. Clue them. What does that even mean? The 2 is not here. This is no longer 5 now, so we have a slight bit less or we have slight more restriction now. In fact, we now know that the 6 is in one of these 2 cells. Therefore, this is definitely not a 6 because well, these are the same digit. So 6 is in one of these 2 cells, so the 6 is in one of these 2 cells. The 6 is also like not up here because of that. So this is 4, 7, 2, or 3. So that sort of narrows down what exactly we're expecting from this 13 cage in this row, but it doesn't make it super clear. We can just clue. Is this interesting at all? I don't think so. What about this 17 cage? Is that interesting? Nope. What about the 20 cage? Is that interesting? I guess, oh, one thing that's interesting is this 4 or 7. If this is a 4, then this is a 4, isn't it? Because if this is a 4, then obviously this digit is greater than 4. And, well, could this not be 6? No, it can't be 6, 7, because then this would be double 7, and that wouldn't work. So I think if this is a 4, then this has to be a 4. So what if this is a 7? Well, then this isn't going to be 9, so then this is going to have to be a 7. So either this is a 4 or this is a 7. And that's not a 7. Wow, this is an interesting puzzle where, like, well, either we have this potential possibility or even another very easy to see possibility. Oh, one of them is obviously obviously, oh yeah, it could go 9, 7. You're right, it could go 9, 7. Yeah. Good spot, Jay. That is very evil. Let's see what Jim is cooking up, or baking up. The row 1, column 9, could that be a 7? By the column clue? So if that's a 7 and that's a 4... Right, then no, this would just be a 4, wouldn't it? Yeah, that would just be a 4. Okay, okay. The lower 9. Oh, the lower 9. There's another 9. That 9, these 2 cells are at least 3 and 4. So this cell is probably a 2, but it could be a 1. I don't know if it can't be 4, that can't be 5. And this definitely has a 3 in it, which is quite interesting because that can't be a 3 now. So if this was a 1, then this would have to go increasing order until we get to the 1. Is that easy, or is that really hard? Wait, isn't it way harder for it to be 2? Because we have the 2 in the row? Yeah, okay. The 1 is ahead of the 2, and this digit is greater than both of them. So therefore the 1 is the first hidden. Duh. So this is a 3, 5, and we know the order. So this is not a 5. There's a 5 up here now. There's also a 3 down here. And we need to increase these 2. And these 2 need to be greater than 5, which they already are by default, so that's cool. 6, 7, 8, 7, 8, 9. Okay, it's not that interesting. Thermo row 9. Hard to say. If this is a 3, This has to be an 8-9 pair. And it would have to go this way because the 8 is already in the row. And is that possible? That is certainly not possible because this will be the first digit not seen. And that's definitely not going to be an 8. So this can't be a 3, I don't think. Unless I'm missing something. Which is not super helpful. I mean, it's cute, but it's not super helpful. The 6 in this box is not here because of this thermobile cells. So these are 6s. We could good lift it. Do we know the 8 is not in it? I mean, the 8 would have to be there, and then the 9 would have to be here, right? And these would have to increase. So there can't be an 8 and a 9 in it, which we already know. But yeah, I don't know. I guess this can't be 8 or 9, right? Or can it be 9? Oh, because then these two digits would be the same digits. So this is a 6 or 7, which is quite interesting. Considering the column. If this is a 6, if this is a 6, no. Yes. If this is a 6, this has to be a 4, right? No, it doesn't. No, it doesn't. That's a lie. That's a lie. Wait, 6. Wait, no, if it's a 7 here and a 6 here, then this has to be a lower digit than 6, doesn't it? So if this is a 6, this is a 4. Which is the opposite of what I was going for. Okay, never mind. Which we already... Stupid. Okay. Row 8, column 9 is greater than row 9, column 9. Right, because if it was less, then these would be the same digit. That's a cube. So this has to be 7, 8, or 9, but it can't be 8, of course. And it can't be 7, right? There's no way this is a 7, 6. That's a 7, 6. What is this digit? That's a 13. That would be another 7. I don't think that's gonna work. Just personally, I don't feel like it's gonna work. Well, good thing we didn't put a 9 here, because that wouldn't work for sure. So now we have 9 plus 6 would be 15, which would need a 5 here, or 9 plus 7, which would be obviously one more than that, so we would need a 4 here, which means that the first digit we see past the 9 will be a 4 or 5, so that's notably not 1. So we get the 1 in this box. So there's also a 1 over here with this 2. If this is a 1-2 pair, that seems really hard. Because a 1-2 pair needs the other two digits to add up to 14. Could be 6, 8. But they also can't be because the 8 can't be hidden. Or can't be the first hidden. So this can't be a 1-2 pair. So this is a 1 or 2. 4, 7 cell comes back. How? I don't see it. Uh, 7 is now hideable in column 9. Oh, I don't know if this happened before, but this, wait, J40, okay, I don't understand the point, but anyways, uh, my point, which I'm not sure if it's the same as your point, but my point is that that row 4, column 9 cannot be the hidden digit, as Jim Baker says. Notably, it can't be the 7, which that's the only place the 7 could be at the hidden digit, because otherwise it would have to be behind the 9, which would be all the way down here, and this is already hidden before then. Therefore, this is not a 7, this is a 4, which means that these are not 4s, which means that this is a 6-7 pair, and this has to be a 4, as we've discussed. This is a 3-5 pair. And this is a 2-3-4, which is totally unexpected. And this is a 7-8-1. We can clean up a little bit. Oh, this 3 down here gives us the 3 and the 5, obviously. Oh, now the 3 is also over here. So this is 1, 2, 3. And we've already confirmed that 1, 2 doesn't work here. And now we have to put a 3 there. Oh, also this is a 4, so this is a 5. So this is a 5, and this is a 6. Yes, a 6. So this is not a 6, so this is a 6. Sorry, I feel like this is like probably what people would have done first, but I did it a completely different way, or an opposite way. Not really opposite way, but you know what I mean. This has a 4 in it, so this is not 4, so this is a 7 or an 8. Obviously, there's a 4 up here now, so this is 7, 8, 9, and 4. I feel like I'm missing a digit in here, but I'm not. Anyways, can this be 1, 3? One 3 would require us to make up 13, which could be 6, 7. We know we can't. So these, let's just good list these. These can't be 8 or 9. And there's no way they can be lower than 4, can they? Well, they can't be 3 because these have a 3 in them. So let's think about this. If they are 4, 7, then we could do 2, 3, right? Yeah, 4, 7, 11 plus 5 is not enough. How did I miscalculate that? Yeah, that's obviously not enough. Yeah, okay, so 5, 7, 2, 3 is the only way would be one way to do it, I mean. Or 6, 7, 1, 3. So there's always a 7 in here. Which seems tough because in both rows here, 7 is not the first cell hidden. And in fact, in both rows, these give big problems because these are going to be hidden. If these are 3 at most, well, we can't go 1, 2, 3 because there's going to be some cell here that hides that cell. So actually, the first hidden, these 2 cells must appear within this box. So, and it's not going to be hidden by this cell. So these 2 cells are 5, 6, 7 with a 7 pencil mark. They're literally exactly that. They have to be exactly these 2 cells. These 2 cells have to be greater than these 2 cells. And we can't be 9s. So we have to hide the 7 some way. We have to hide it with an 8 right there. That has to be a 7. That has to be a 7. The 5, 6, 5, 6. And now the 9 goes right there. This has to be hidden by something, and we don't have any digit greater than 6 to hide it with. So this has to be a 5. This has to be a 2, 3. Has to be a 1. That's all very smooth and very, very cool. We also, I think, no, we didn't know the order of that. My bad. That's an 8, that's a 4, that's a 7. That's an 8. These are obviously not going to be 8. Yeah, row 5. Yeah, okay. Yeah. We're all on the same page. Good spots to J40 and Doomed yet. 13 gauge also interesting now, Piato says. Piatato? Piato. Probably, yeah. 2 or 4. I mean, if it's a 4, then we're obviously gonna do this, right? Like this is the only way to do that. But then this is 6, so this would have to be a 7. I don't know, this feels a little bit bifurcated. Well, we can't get this higher. We can't get this to be higher than 3, right? Because this is going to be the first cell hidden if this goes 2, 3, 4. So that would be a 1 then. So either this is a 1 if this is 2, 3, 4, which would mean this is a 1, 2, and this would have to be a 10, which obviously doesn't work. So that's not going to be the case. Or this is a 2 or 3. So these two add up to 7 at most. So this can be a 6 at most. Or at least. At least, yeah, at least. This is a 6 at least. No, it cannot be 1 because oh, goodbye hippo. Have a good one. Because if this was a 1, this would have to be this, but then this would have to be 10. No 8. You are correct. 8 would work with 2, 3, right? 2, 3, 5. With a 4, 3, yeah, that would work actually. So I guess we're asking, what can this? How does this get hidden? Oh, I was responding to Pietato, Doomed Yet. Can't hide the 1 in the row. Make the math work in the cage. Oh yeah, okay. So if this is a 4, then this is 2, 3. That's just how it is. So this can't be a 4. It needs to be a 3. Good spot, Pietato. So then the 3 is definitely hidden, but we don't know if it's the first hidden. The 2 could be the first hidden if this is a 4. But we do know that one of these two cells is a 2. Because either this is the hidden 2, or this is a 2. So we have 2 plus 4 or 3, which means we're never doing 6. This is never a 6. But this can't be the first hidden. Oh, which means it also can't be a 1, because it would be the first hidden then. And this can't be a 6 for the exact same reason. So this is not a 6, means it is a 9. This is a not. So this is the first hidden, which means it's a 7 or an 8. Which gives us a 7-8 pair, which makes this a 4, which makes this a 2. Wow, that's really clean. I really like that. So this is a 3. We have 5, 8. So this is an 8, this is a 7. That's an 8, that's a 1. A 1. I looked away for half a second and then typed in the wrong digit. So this 8 gives us a 9 here. which gives us an 8 here, and a 7, and a 9, and a 7. And the 6 here gave us a 6 over here like forever ago. I don't know why I didn't see that. Well, I guess it wasn't given, but you know what I mean. These 9s fill in the last 9 into this spot. The 7s probably do the same. Yep, right there. 6s do the same, yeah. Right here, which gives us a 3. And this digit can't be greater than 6, so it needs to be the first hidden, which is going to be 3, which makes this a 2, that a 3, that a 2, that a 3, that a 1, that a 2. This is a 1 by the column. These are 4 and 5 by the box, so that's a 4 and that's a 5. Woohoo! That was a really good puzzle. I really enjoyed a lot of that. I really like some of the logic where, like, if we put a 9 here, then these would be the same digit. And I also liked when we thought there could be a 9 here, but then there was a 9 here. That was also really cute. I really like the use of, like, previous information to get the next piece of information. I think that was really well telegraphed. Some of it was really well telegraphed in this puzzle. I didn't feel like there was any sticking points either. So, yeah, awesome. Nell is great. I think this is a pretty early Nell puzzle too, so yeah. I wonder if Nell's early or later stuff is even better than this. Anyways, I'll put in the solution later, but I will take a quick break here and be back for some no solutions in just a moment. Hello, hello. Welcome back, everyone. What's happened to the puzzle? There we go. Well, I went to get a little snack and ended up spilling cracker crumbs all over the floor, which is great. I'm sure my cat will clean that up. Uh, but in the meantime, we can have a look at this no solutions puzzle by Andrew Sakis with a 159 and XV. So XV is just these cells separated by x's sum to 10. For example, 4 and 6, if you don't know what summing to 10 means. And these mean that the two cells sum to 5. So, and the, oh, right, the sorry, not the XV. The 159 means that whatever digit I put in column 1, in that row, that is where the 1 goes. So this means that it goes in the 4th column, and the same thing is true for the 5s and the 9s. So if this was 8, for example, then this would be a 5. If this was a 1, then this would be a 9, and these would sort of index each other. But we don't have to solve a whole puzzle with this. We just have to answer this simple question of why does this puzzle with these things put in have no solutions? And I believe what we have to appreciate is that there's going to be a 1 in each of these 3 boxes. So in one of the boxes, the 1 will be in the first 3 cells, and then the other box will be in the next 3 cells, and then the last box will be in the last 3 cells. Well, not necessarily in that order. We could have this, for example, but we're always going to have the ones in box 1, a 1 in box 2, and a 1 in box 3 in each row. So there's always going to be a 1, 2, or 3, a 4, 5, and 6, and a 7, 8, and 9. And that's the low, mid, high trick to 1, 5, 9. So notably, these are 1, 2, 3, 4. So this is either going to be, well, one thing we can note also is that the digit 5 can't go on the X, so the digit 5, and it can't go on the V either, so the digit 5 is in one of these 2 cells. So I guess we could mark that the digit 1 is in one of these 2 cells, but I don't think it's probably going to matter. You can remove the V and it still works. Interesting. Oh, it works without the V. I see. So the V obviously has to be from 1, 2, 3, 4. And we also need at least 3 1, 2, 3, 4s in the column to make up for the 6, 7, 8, and 9s on the X's and V's. One of these is going to be like a high digit, one of these is going to be a low digit. Oh, but we can never have, these can never be 4, 6, because if it was 4, 6, well, let's do this one for the sake of it. If this was 4, 6, then this would be a 1, but also this would be a 1. So 4, 6 can never be on an X that's completely within the column 1, or any column for that matter. Well, any column clue. 1, 5, or 9 column. So then we know that these 3 digits will have to be 4, 5, and 6 because we have our 1, 2, 3s, and we have our 7, 8, 9s. So these will have to be 4, 5, and 6, and obviously this can't be a 4, 5, or 6. Or sorry, this can't be a 5 or 6, so it has to be a 4. I don't know why I said 3 digits when I only meant to say 2 of them. So then these will be 5 and 6, of course. And this 1 obviously knocks out the 1, 9 candidates there. But you might look at this row and say, well, hey, that says 4. but but that's not where the 1 is. So yeah, it's broken. But you might also say, hey, meme, why didn't you just say that this could never be 1 4 in that order, because it can't be 1 4 in that order at all. So therefore you have too many 1 2 3s. Which is another way of thinking about that, which is pretty cool. Yeah, I think now a cool break-in might be the 3x's, but in a non column 1. Because if you had 3x's in, say, column 5, for example, then you know they can't be 4 6's for the same reason. So you can limit the other ones to being 4 5 6, for example. That's pretty cool, though. So we have too many 1 2 3s in the column. Yeah. Cool. Yeah, there's definitely some ways you could make this into a nice puzzle, a nice break-in. All right, let's move on to speak of the devil, MicroStudy, who just spoke in chat, who has this arrow X puzzle. The devil, yes. Arrows, of course. Yeah, broken 159 is pretty cool too. This, of course, not being a broken 159, but being a broken 159. You can see the difference there. So arrows are, as we discussed before, these 2 digits have to sum to this digit. The same is true, of course, of these 2 digits sum to that digit. And the diagonal says that no digits on either diagonal repeat. So these are a set of digits 1 to 9, and these are a set of digits 1 to 9. Just like any row, column, or box would be a set of digits 1 to 9, these are also another set of digits 1 to 9. So we can do some summing tricks here, and we can treat these. We could treat these arrows. Trying to think if it's parity that we're supposed to do, or if it's maxes and mins. Well, we have 5 digits here, right? So those 5 individual digits sum to at least 15. Therefore, these digits sum to at least 15. So we have a minimum of 30 in these cells. The same can be said of these cells. We have a minimum of 30. And also 15 can only be made of 6, 9, or 7, 8. And obviously, if these are greater than 15, they have to be greater than that. So that's that. But if these do sum to at least, they sum to at least 30, we know that. So then these 2 would have to sum to the remainder, which is maximum 15, but I guess minimum. Well, they can't sum to 15. If these 2 sum to 15, then they would be from 6, 7, 8, and 9. But obviously this middle one can't be 6, 7, 8, or 9, because it would see all of 6, 7, 8, and 9. If I just put in 6, 9 here, for example, then this obviously has to be a 7, 8, and this sees all those digits, which means that couldn't be any of them. So obviously these can't sum to 15, but it could sum to less than 15, because that's the maximum that it can sum to. Right? Yeah, that's the maximum. So obviously we need to make these sum to more than 15. I guess the maximum they could sum to be an 8, 9. which is 17, and 17 times 2 is going to be 44. I mean, these would sum to 1. No, wait, what? 34. 34. Oh, no. 34. 17 times. So these would have to sum to 11. To fulfill the secret, which is 45, of course. Oh, yeah. Thank you. Obviously, what I just said with these not being able to repeat means that these do sum. Means that it does have to be that way. I mean, so these sum to a minimum of 15. We just discussed that because of the 5 digits. If these are minimized, they would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and those sum to 15. So then the ends have to sum to 15 as well. So they have to be from 6, 7, 8, and 9. But all of these digits see each other, which I just said, because this digit sees all of those. So that means that all these 4 corners have to be from 6, 7, 8, 9, but there's only 4 options, so they all have to be different, and they are 6, 7, 8, 9, which means that they sum to 30. So these sum to 60, so this sums to 15, this sums to 15, well, not necessarily, but at least, right? Yeah, these, not necessarily. Still, it's definitely broken. I can see that it's broken, but I can't. For some reason, I'm having trouble articulating. Probably because I thought 17 times 2 was 44. Okay, so let's articulate this in the nicest way possible. Okay, we can't make them more than 7. We can't make them more than, yeah, we can't make them more than 16 because 15. Because if I tried to make this like 8, 9, right? Then this is going to be 6, 7. And 6, 7 will mean that this has to add up to 13. Well, we already established that it adds up to 15 at least. So therefore, it must add up. They both have to add up to 15. It has to be a 6, 9 and a 7, 8. There's no other way. Because if you tried to make one bigger, then the other one is going to be smaller. And that's going to be smaller than 15. Duh. So then we've already established that if these both sum to 15, then these sum to 15. Even just one of them summing to 15 is a problem because this would have to be from 6, 7, 8, 9, and that is not going to work because it sees all of the other cells. Whoopsie. So yeah, I feel like that one has been proved at this point. To death, at least. At least to death. All right, moving on from that mess. For some reason, this puzzle made my brain spin. Let's move on to a thermo no solutions by Tall Cat. These thermos just have to have the digits increase from the bulb end, so we could do like a 1, 2, 4, 5, 6, 9 sort of thing. This digit just has to be bigger than this digit, or otherwise this digit has to be smaller than the next digit along the line, whatever you want to think of it as. And this puzzle will have no solutions. Our job is to prove that it does not have any solutions. Well, we can immediately see something is going on with this. Because these digits, these 2 digits, let's just call them blue. These blue digits, well, they can't go there because then they'd be bigger than themselves. So they have to either go here or here. But if either blue digit went on here, then these would be very small, right? So let's say one of the blue digits goes on there, right? But then one of the blue digits doesn't go in there. Then this digit, let's call it red. Let's call these both red, actually. Then one of the red digits will be able to snake its way into here, right? But the other red digit will have to go in here. And that digit will be both less than blue and greater than blue. So if I try to put a blue digit here, then this happens, right? But I could put both blue digits here. And then both red digits here. And this would be fine. But that's the same thing up here. So we'd have to do something like this. And the ones in the column are always going to be the lower of the two. So our question is, how low do these low digits have to be? This is the testing. Yeah, they've been tested. I just trust you guys. I trust you guys that you haven't... If it's broken, right? Is it broken, no solutions? Is that broken because it's broken, or is it broken because it's broken? Or it's not broken? So wait, so if this is, let's see, this is the minimum for this, right? So these are minimum 1, 2. And this is obviously a minimum of 5. So this digit is a minimum of 5. We're doing the wrong thing. We're supposed to be looking at maximums. I don't know why I'm looking at minimums. So if this is a 9, well, it can't be a 9. What am I doing? Okay, right. What's the maximum this digit can be? That's the question I should be asking. Well, 6, 7, 8, 9 would be the maximum that digit can be. So 6, 5, 4, 3, 2. These can be 2, 3, or 1. But that means that these are also from 2, 3, 1. And that means that we only have 3 digits, which these can be, but we need 4 digits in column 5 to be from that sort of set of digits. So we have too many low digits in column 5. Hopefully that all made sense. And now we will go and solve real puzzles. And hopefully they won't break my brain as much as, for some reason, the error. Okay, so I'm going to switch out these for these. We might end up switching out singular puzzles eventually, but for now, we will do this because it's quicker. Some of them are real, but some of them I don't think are real. But I'm on the fence about it, actually. Not sure. My fiance just texted me, and all she said was, I feel so weird. I don't know what's going on. Good morning, Caravan. Welcome. Oh, we have a complete tie. 33% across the board. All right, we're going up a little bit. She said, I feel like my head isn't attached. And she had physiotherapy yesterday on her neck, which is probably why. All right, number 2 is leading. Pietato and Aeronymous. Aeronymous. I think it's still attached. She's still at work, so I can't really check on her, but all right, I will call the voting, I suppose. That's a good reason to pick something, Lekia. Uh, and I will paste the link to this one in the chat, and then we will get going. To the screen, hopefully the puzzles will come up when I bring them up. Let's see here. We want to find coordinates, right? Of course they won't. Nice. Coordinate arrows. Oh, I want this one. Coordinate arrows. Come on, OBS. Work with me. All right, I think everything is on the screen now. Hopefully you can see me all right. And this beautiful puzzle in front of us. So we have coordinate arrows. So normal Sudoku rules apply, 1 to 9 in every row, column, box, with no repeats. And then the coordinate arrow rules themselves. True. It does say just by Pietato, but I think in the LMD page, it's mentioned that Hieronymus is a collaborator of this puzzle. So take Pietato there as a grain of salt. Coordinate arrow rules apply. Digits on an arrow spell out the coordinates for the digit that is in their sum. That is their sum. For the digit that is their sum. Okay, interesting. So if, for example, an arrow looked like this, 1, 4, then there must be a 5. So the sum of 1 and 4 is 5 in row 1, column 4. And that's all we have. All the arrows must correspond to different coordinates. That's also, we have that as well. Interesting. Okay. So obviously the diagonal is interesting because that would require us to repeat digits. There's quite a few arrows here. How many arrows do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 arrows. And I guess we could even clue a 2 if it was right here. But we can't clue that many digits because, well, we just can't. I mean, you can sum to 2 with double 1, but I mean, you can never clue anything in these cells, right? Like these can't clue a 9, right? Because that would be off the grid. You could clue a 9 in row 8 or column 8, but not, well, oh, well, you could only clue an 8 if it was, or sorry, you could only clue a 9 if it was in, sorry, you could only use an 8 to clue a 9 if it was in these two cells exactly. But then if you did that, then they would be on an arrow. So you can't use an 8 in any of these, is what we're learning. There are no 8s or 9s on any of these cells. Let's just give these a color. Maybe like a little, not a gray, maybe green. So what about 7? I mean, you could do 7, 2, so these cells, I guess, is right. But those would have to be 8s or 9s. So again, we can't use a 7. Right, the negative diagonal and below can't be indexed to. That's a good way of putting it. So all these cells can't be indexed to, and neither can these two cells, and neither can these two cells or these two cells because of the fact that they would need to be 8s or 9s there. So I guess we can give those like a light gray, maybe. I'm going to put on the column and row. There's so many settings nowadays. Where on earth is the column row labels here? Row column labels. I don't know why that was eluding me, but I'm going to turn that on just so we can easily see it. So that means 7, 8, and 9 are in these 3 cells because they can't be on arrows. Seven in this box is in 3 different cells. Don't know if that's worth labeling, but something. Let's think here. What about 6? Think about 6. So 6 could go in any of these cells, or sorry, in any of these cells, or sorry, the 6 could index one of these cells, but that would have to be a 7, 8, or 9. And well, these can't be, right? Because that would be an 8, and that would be a 9, and that would be an 8, and that would be a 9. Or sorry, that the other way around, but still. So these also cannot be indexed, these two, by the 6s. So but these could be 7s and be indexed. Right. So there is a 6 on one of these arrows, and it has to refer to the 7 in one of these 2 cells. Right, that's a good point. That's J40's point. So the 6 is on one of these arrows, and it has to be accompanied by a 1. Is the row... the row number is written at the start of the arrow, and the column is written at the arrow tip. So these two are saying row 6, column 1. Whereas this one could be saying row 6, column 1, or row 1, column 6. Yes, those 3 arrows must point to a 7 either here or here. So there's a 7 in one of these 2 cells. Oh, excuse me. Okay, maybe we just continue with 5. If 5... So these 2 can't be indexed because those would be 5, 4, and that would be a 9 there. But we can't put a 9 there because then that would index 10 or greater. So these are not indexable. These could be indexable because they could be 6s. 6, 1. Oh, but you can't index 6, 1 twice, right? But oh, you could do... Well, 6 is here. would mean that's the 6th row, right? Yeah, 6th row, first column. Hmm. Yeah, we can have, if we do a 6-1 here, we can do a 1-6 down here, because those would be different cells. But then these would both be 7s, and we would have to have a 7 right here, which is possible. Just 1 second, my cat is disturbing. I was gonna grab him for you guys, but did not want to come. So let's take a look again at, I mean, these could be 8s, right? Indexed by the 5-3. Or this could be an 8 indexed by the 4-4. Yeah, okay, so we don't have a lot of leeway, but I guess what we could think about is the 5 down here. I mean, the 5 has to go with at least a 2, right? So that's going to index another 7. I'm not sure you can convince him. He's pretty stubborn. Uh, so the 5 can't go with a 4. Because we've ruled that out. So either the 5 goes with a 2 or a 3. So, but you can't go with a 2 here because there's a 7 looking at a spot. Or a 3 here. So wait, so 5 can't be in the row, so it can't be on the end. 5 can't be on the end at all. So 5 has to be on the tip. Oopsie, I got rid of the 6 there. So one of the arrows in box 9 has to be index of 8 or higher. You could do 5 and 2 and 3 and 7. Or 3 and 4, sorry, 3 and 4. Oh, but 3 and... Oh, yeah, you're right. Oh, that's really cute. Okay, so we can't do that, because if we did 5 and 2, 1 and 6, 3 and 4, right? Then we're doing that, this is a 7, that the second row, 5th column, that's a 7, but then there's also a 7 in the 3rd column, 4th row. Or sorry, 3rd row, 4th column, whichever it is, if it's this way or if it's that way, then as I think J40 says, before he said only 2 7s can be indexed, which I didn't understand, but now I realized that there's only 2 boxes on, as he now calls it, the 7 diagonal. Right, so there, yeah, this is interesting. Okay, so then the 5 just can't go with the 2, because if the 5 went with the 2, then the 4 would go with the 3, and then we're broken. So actually the 5 2 spots cannot be indexed. No, wait, right. They can be indexed. They can't be indexed in this box, is what I'm saying. The 5-1 also can't be indexed from this box, but it could be indexed somewhere else. So the 5 in this box goes with the 3, and the 4 in this box goes with the 6. So one of these two is a 6. Therefore, this is a 1. And these are both 7s. Yeah, that's true. Because one of these will be a 4 and a 2, which will put a 6 in one of these 2 places, meaning that this is a 6-1, and that will clue the 7, but then we can't clue that 7 twice, so the 6-1 down here has to be like this. Right. So now in one of these two cells, we have a 3 that goes with the 5, which will clue an 8 in one of these two cells. Make those blue, and we'll change out the blue. And we also have one of these two cells being a 6. All right, not blue. I want to do orange. Oh, well, can't always have what we want. How many of each digit can be indexed based on the negative diagonals? That's an interesting question. So I guess the 8 can be indexed 3 times. The 7 can be indexed twice. The 6 can be indexed twice now because we've taken one of its spots. The 5 can be indexed 1, 2, 3 times. That's 10 so far. And the rest of them can only indexed once. That's another 3. That's 13 possible indexes. But don't we have like 12 arrows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's only one, wait, -1? Well, this is the 5 diagonal, and then there's the 3 diagonal, and then there's a 2 diagonal, and then there's the, wait, what am I doing? This is the 5 diagonal, then there's the 4 diagonal, the 3 diagonal, and this is the 2 diagonal, the 1 cell. The 1, I wasn't counting, I don't think. Maybe I'll count again. Okay, yeah. The 1, we discussed that at the beginning. The double 1 diagonal arrow could exist somewhere. It's actually running out of spots because it can't exist here. It can't exist here. Could be there, or could be there, or could be in one of these two. Well, let's focus on this right now. This is 3. Yeah, these can be pencil marked a little bit. 7 in box 5. Oh, 7 in box 5 is of course placed here because we talked about that. Oh, that removes a spot that could be indexed by the 8. So now we have one less, which is 12. We have 12 spots. So actually, we know that this is a 2, that these have to have a 3 in them, these have to have a 4, these have to have 5s, these are going to have 5s. There is a 6 in one of these two. There is a 6 in one of these two. That 6 is seen now, so that's a 6. There can't be 2 of these, so that's actually not a 6. So this is a 6. And these are both 8s. Yeah, we know all this. Wow, that's crazy. What a wild puzzle. So now, what about the 6 in here, maybe? No, the 7 is in these 3 cells, the 8 in these 3 cells. 9 can be anywhere we want it to be. But we do need a double 1. Let's get rid of these colors here. Yeah, the given 6 is really strong, given this arrow formation. Well, we know we need double 1 in one of these 3 arrows. Can we get anything from that? I don't think quite yet. Well, we know that the 6s are both in the 2, 4, and also the 1, 5. Oh, okay. So this is actually interesting. We know it's 2, 4, right? Or I always forget the order of this. The row is written at the start of the arrow, and the column is written in the arrow tip. So it's in row 4, so the 4 is the first digit here, so not the 2. Interesting, okay. And then we also have a 1, 1, 5. So there has to be a 1, 5 arrow. So this one couldn't be a 1, 5 arrow. The 1 needs to be here, and the 5 needs to be at the end. Excuse me. So we have a few, not that one. Not either of these two. Oh. Wait, there's only one place that this 1, 5 arrow can be. It's only there. That's awesome. That is nuts. Okay, so there's 2 spots for 5 in here. 2 spots for 1 over here. Two spots for 1 in here, which are both on arrows. Interesting. I guess we can also track the 9s, which are quite limited as well in certain boxes. So what about the 8s? Those have to be 5 and 3, right? But the 5s are really limited. Well, we have 1, 5, 3. We also need the other 3, 5. Wait a second. That means the 5 has to go at the end of one of these arrows. But, like, there's only... Well, that one doesn't work. 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 So it's only this one. That's the only place it could be. That is whack. No worries, Sarah. Welcome. We're glad to have you, no matter how late you are. How did we figure out the order of the 3, 5 in box 5? Or in box 9? We just figured it out. Actually. I don't think we actually knew that before, but now we actually do know that because the 5 can't be in any of the tips. I don't think we actually knew that before. We do know it now. Good spot. Okay, now we know the order of this. Oh, we know both of these now. So this has to be the 2, then the 3, right? Yeah, 2, then 3. 2, then 3. So these can't have like the 3 can't go there. So this could work, that could work, that could work. Oh wait, that can't work because there's a 3 in there. So it's either this one or that one. So there's definitely a 2 in one of these two is the thing. Right, okay. There's definitely a 2 in one of these two, which has the 3 at the end, which is clearing this. Whereas this is saying that the 1 comes, then the 2. So these can't have either, because the 2 can't go there. 2 could go there, and but that can't be a 1. But this could be a 2, 1. This can't be a 2, 1. So is this the only place for a 2, 1? I think that's the only place for a 2, 1. That's how you set this puzzle. This is wild. Now this is the 1, 1, because that was the only other place for the 1, 1. Why do I have a 1 pencil mark here again? There's so much to remember here. In row 1, we have the 7, we have the 6, we have the 5? Well, this is the 3 for sure. We don't have the 5, do we? We didn't clue either of these 5s, right? So these are both 1-4s, right? Am I crazy? Wait, that's the same clue. Sorry, wait. 1-4 and then 4-1. Yeah, okay, okay. I'm not crazy. That's true. So the 9 is down here, which marries up with this 9, placing a 9 up here. Yeah, now it's like a classic Sudoku, basically. The 3 in this box has been placed here, which means that the 9... Oh, the 9 also marries up with this 9, but that's way worse. You can also just label these. That's not a 6 either. New catchphrase. I'm making all kinds of new catchphrases today, apparently. The 9 and 2 are actually fixed in this box. 2 goes down here now. 8's not useful. The 8 would go on that arrow. Oh, I did not even see this arrow. I didn't even see this arrow at all. Wait. Can that even be an 8? I think we did the 1-4s really fast, and I don't think it's true. Oh, yeah, J40 is right. It could have been, the double 1 could have still been here. Yeah, okay. I did not even see this arrow. I just completely missed it for some reason. But I guess that doesn't even affect the fact that the 1-1 doesn't have to go here, or doesn't have to go here. But I totally missed this and just filled in the 4-1 because I thought those were the last arrows. Okay. The 2-3 is here, right? We do know we need 8-9 in row 1, right? So that is helpful. So that's gonna help us fill in the 9 and the 8. That's no longer a 9. So this has to be a 1-4. And that can't be a 4. So that's a 1, that's a 4. Which means that this isn't double 1. Big surprise. So this is the double 1. There's no other place that the double 1 could be, right? I'm not missing something? Okay. I think I'm not missing something. We need a 4-1, but this can't be the 4-1, and this would be 4-4, so that doesn't work. So this has to be 4-1. That's not a 4, so that's a 4. We need a 1-4, and we need a 1-2. No, wait, what? 3-1? Oh, we need to clue the 3-1, right? Duh. Okay. Embarrassment aside. So this is a 2 and a 9, which still go in. This, we got that before somehow. Oh, that's a 3, duh, because there's 3s here. 7 in one of these 2 cells, 8's in one of these 2 cells, and 6 is placed here, so that's going to give us 6, 8, 7. I was just waiting for it to place itself instead of filling it in. 4 and 9 go in. So this digit should be known. That's an 8. Completely unhelpful. 9 is down here with a 2. Completely unhelpful again. This is 6, 7, and 4 this time instead of 6, 7, 9 as it was before. What is this? This is 6, 8, 9, and 3. So those aren't 3s. That's not an 8. That's not a 6. Well, that's not helpful at all. Oh, I guess we could fill in these. That's probably better than filling in these, huh? These need 3, 4, and 7. That's a naked single, which is going to give us a 3 here. They're not 3s. That's also not a 7, so that's a 4. So that's a 7, so that's a 4. 7 is being completely unhelpful and ruling out 7 from the same cell we already had. 7 out of. Not cool, bro. Not cool. Keep looking at box 5, but I can't see anything helpful there, so I guess probably this is going to be helpful or something. What is this? 2 and 7? Oh, that's super helpful. 2 and 7 go in, which gives us the 9, which gives us the 8, which gives us 7, and probably going to resolve like the whole puzzle. Good. 8 and 9 go in. Row 4, column 7 is shy and hiding. Oh, it's a 1. Cool. Or wait, could it be a 9? No, it is a 9. Actually, it is a 9. Or is it a 1? No, it's actually a 1. It is actually a 1 because these 4 ones are looking into this box. There's nothing about naked singles. It's just a 1. It's pure luck that was correct. I was thinking it was a naked single because it saw every digit except for... Oh, I guess it doesn't see 8 either. It could have been 1, 8, or 9, and for some reason I just decided it was going to be 1, and it is. So, you know, what can I say? 5 and 6, so that's obviously going to go in like that. This is a 2. 5 and 6 again. 5 will go down there. This is a 4 and a 3. We need a 5 in that row. Oh, no, we don't. We definitely do not need a 5 in that row. We need a 9 in that row. We don't need 5s at all. Don't think about 5s. That's a 4 now. And yay, congrats. Done. Excellent. Okay. That was a cool puzzle. I enjoyed the maximal. It definitely felt like I needed to think about the things that I actually needed to think about, which is always great. Now try the hard mode version of this puzzle. Oh boy, I don't. That was enough hard mode for me. All right, maybe we can do some no solutions when my brain is possibly still working, and then take a little break and come back and do another longer puzzle there. Definitely, yeah. Okay, so this is another thermo, this time by Logan Wall. Both Logan and Paul Cat are supporters on Patreon. If you want to support me on Patreon, check out the link in the description. So the digits increase on the bulb end, just like before. Just means that this digit has to be greater than this digit. That's what increase means. I always feel weird explaining the rules because it's like, yep, that's what I said. So these are all long thermos. So this is, what is this? 1, 2, 3, 4, 5, 6 long. This is at least a 6. 4, 5, 6, 7 long. So this is at least a 7. And this one 1, 2, 3, 4, 5, 6, 7 long again. So I guess we can mark this, or yeah, mark good lift it, because this can't be a 6, was what I was gonna say. Is this a... no. I guess we can good lift this one too. No thoughts are entering my head that are helpful. Maybe it's also the low digits that we have to think about. I mean, these sort of interact, right? This sort of interacts with this. Okay, so what's the lowest? I mean, what's the highest this could be is 4, right? And this is the highest 3. No, Alexa, I didn't ask a question. What on earth was that? I'm gonna have to go back and listen to that. What the heck was that? Okay, so 3, 4, 5, 6 is not gonna work. So I hope you guys could hear that. That was just so weird. Okay, so box. Where do all the currently marked digits go in box 6? That's a good question. Oh, that's a great question. Well, these 3 digits are obviously these 3 digits. So now we can ask, where do these digits go in box 6? That's easier. Where do these 4 digits go in box 6? Well, we just said that these 3 have to go there, so this one will have to be one of these. But that's not going to work, because this digit is not 1, 2, 3, or 4. It is 6, 7, 8, or 9. So it's the little deduction that this can't be 6, which limits that this can't be 5, which means that this can't go there. So there's too many high digits in here that can't go there. That's pretty interesting. Is there more going on? Even more? So Urban's saying the 2, 3 in this box, where does it go? Oh yeah, okay, so no. I guess another way to see it is, where do these 3 digits go in this column? And because we limited this, because this can't be 6, because that would mean that these are 5 digits from 6, 7, 8, and 9. Or 5, 6, sorry, 5 digits from 6, 7, 8, and 9, which are only 4 digits, of course, then these 3 digits have nowhere to go in this column. There's only 2 places that they could go because the rest of them cannot be that. All right, that's pretty cool because this is like the crucial deduction, which is not a very hard deduction. It's actually quite well telegraphed with this whole thing. So, yeah, I think that's pretty fair and pretty cool. I feel like this could have been drawn a little bit differently to not confuse us as much, but yeah, good puzzle. Yeah, I like that puzzle, and yeah, it's really interesting how this works, and it could be used in a different way for a regular solutions puzzle. Regular solutions, that's what we're calling them now. Okay, let's move on to an entropic lines puzzle by Rom Planer. This is using entropic lines, so every 3-cell segment must contain a low, mid, and high digit. So one of them has to be from 1, 2, 3, one of them has to be from 4, 5, 6, and one of them has to be from 7, 8, 9. So if this was like a 1, then these couldn't be from 1, 2, 3 because they would have to have a 4 and a high digit as well, or like a middle digit. This could be a 5 or a 6 as well. And then these 3 digits in this segment also have to be mid, high, and low. So I almost filled in the wrong one there. And then these also have to be from mid, high, and low, so you have to do that. And then these also have to be mid, high, and low, so you have to do something like that. And then these would also have to be from mid, high, and low, so you have to do something like that. And I'm not going to say that over and over again. Thanks, Sarah. Yeah, I don't have 1,000 subscribers yet, so I can't do YouTube membership sort of deals or get monetized or for some reason forward to another stream after my stream is done, which I find that's the weirdest one. I find YouTube doesn't trust me. I'm like a young child apparently. All right, so we have to figure out what's going on. Well, we can color. So these 3 are going to be the same parity, low, mid, or high. These 2 are also going to be that, and then yeah, we could do that. And then of course, one of these will be red and one of these will be pink or purple if you prefer, or 5 if you prefer. Thanks, Sarah. So then I guess maybe we can do more coloring. I'm not seeing this one very intuitively, so oh, we can't color that same color. Obviously, it might be a different color. So this means that green is not pink. That's all it means. Pink and red. Yeah. Yeah. Okay. Is this one right at least? I think this one's right at least. Yeah, I think this one's right. Yeah, stop sign meme edition. I have to use that one a little bit too much, I think. So now we don't know anything about green. Column 5 is just broken. Oh, that's really cool. Okay, so let's just do more of this, I guess. Blue and this, that's too close to the other red. This one. Okay, so now these three are different parities because we know because these three are different parities, right? So these are three of three different parities, right? So if I have like 1, 4, 7, 2, 5, 8, right? These are a low, medium, high, low, medium, high. Then this will have to be, again, low, medium, high. It doesn't matter the order of these things. I just know that there's a low, there's a medium, there's a high in these three. So there's basically what we can do is we can just draw a little entropic line ourselves in these two boxes, because that's what it basically is saying, is this, and this have to be one of each parity. But then we also know that we have 3 low digits, 3 high digits, and 3 middle digits in the column itself. So there's another invisible entropic line in box 5, but this R shape means that these two cells would have to have different parities, but, or sorry, the R shape means that they have the same parity, but they can't have the same parity. They need to have different parities. So there we go, as J40 says. Column 5 is just immediately broken. Memrister, stop, addition, stop sign. Stop what you're doing, it's broken. But that's the point, it should be broken. Okay, so we'll do one more of these, and then we will go back to solving real puzzles. But that was a nice one as well, yeah. Rom planer, always a great setter. Okay, this one is Kropke Whisper by Directionary, or the Jor, if you prefer. And Derek had actually donated to us, so it's good that we're doing his puzzle. Okay, on green lines, adjacent digits cannot have a difference of less than 5, so if this was a 5, then it would be broken because you can't put a 0 or a 10 into a Sudoku. If it's a 3, then you need to put something at least 5 way, which could be a 8 or a 9, but not a 7 because that's only 4 away. Invisible entropic lines is what I will tell you, Sarah. If you want to work it out yourself. Links of these are in the description, by the way. These are broken scooters, apparently. Sequel to the purple scooters. I can't remember who that was by. I don't want to say like Rocky, but I know that's not true. Maybe T-Rex? Can't remember. It was by Derek. Duh. Big duh. Okay, so the black dots are 1 to 2 ratio, so that could be a 1 and a 2, because I think 1 and 2 are pretty obviously a 1 to 2 ratio. Or it could be a 3 and a 6, for example, because that 6 is double 3, or anything else that works like that. And 3 things that don't work like that are, of course, 5, 7, and 9. So these can only be from those digits, which means these will have to be 5, 7, and 9, but I'm pretty sure that doesn't really matter. But also, the 3 could only go with the 8, so, and the 4 can't go with anything. So there's no 4 on these lines. And there will need to be a 6 or 8 on one of these lines. So the 6 can only go with the 1, right? So there's no 1 in here. Definitely a 1 on one of these two. If the 6 went up here, then the 3 would go down here, which would mean that the 3 couldn't go with the 8 over here. Why does that matter? What I'm saying is that there can't be a 3 on here. That's what I'm saying. There can't be a 6. What is the joke though? What is the punchline? Why is this broken? So let's think here. This feels like one that I figure out and then I have to go back and actually explain it nicely because this is not a nice explanation at all. No 8 off the lines. Right, obviously this can't be an 8 or a 6, right? Because, yeah, so this can't be a 3. So this is a 3 with a 6 above it. Because if there was a 3 over here, there would have to be a 6 down here, but then there couldn't be a 6 on the line in the box. So that means there is a 3 on here. There is a 6 on here, so there's no 6 on here. So there's no 8 on here. Which means that there is a 1 on here. But the 1 has to go with the 2, not the 4. But now, this is broken because you have to repeat the 2. The point is, I think, if we want to restart this, the point is that the 4 can't go anywhere. Because these are 5, 7, and 9. And the 4 can't go on the lines, right? But if the 4 goes on here, then this has to go either with an 8 or a 2. Which doesn't immediately strike me as being obviously the case, but 2 can't go with 6. 8 could go with 3. Did I mess up? Could we not just do 8, 3, and then 6 and 1, and then... Oh, because the 3 goes with the 6, duh. The 3 goes with the 6. I don't know what I'm thinking. So what's the easy way to see this? So we have to ask the question about the 4, and we have to ask the question about the 3. So the 3, if it goes on here, then it goes with the 6. But the 6 has to be on the line because there's only 2 high digits. So the 6 has to be on the line. So the 3 can't be on the line. Is that the point? Well, the 3 can't go with the 6, obviously. So one of them goes up here, which means the other one goes down here. And the 6 has to be on the line, so it has to be like that. And now the 4 with the 6 doesn't make any sense because the 6 can't go with a 2 or an 8. Okay, that's a much easier way to see it. Yeah, it's broken in so many ways that it just gets confusing. Bye, Piato. Pietato. Directionary, yeah. Okay, Derek connection. Yeah, Derek directionary is such a different pronunciation of that word. Ugh. It's such a hard word to pronounce. If 6 is on the bottom line, 3 would be in a different box. But then, Sarah, where do you put the 3 in the box? Because the 3, if the 3 goes on any of these cells, then the 3 and the 6 go together. So if you put the 6 down here, you'd have to repeat the 6 here. Yeah. It is confusing. Definitely. Okay. Now we will let's not take a break. Let's just go straight into another puzzle. The puzzle pick. So I might have muted myself for a second there. Let's just go straight into a puzzle from the puzzle pick. And then we'll do this one. We'll do 3 more no solutions, and then we will wrap up. I need to put a poll because otherwise you don't have a vote. What puzzle? 1, 2. I put 10 by accident. 1, 2, or 3. Okay, 1, 2, or 3. Let's go. So we have Another puzzle by Directionary, Diagonal Sandwiches. We have a puzzle by Doomdiat, Masu Latin Square Loop Ambiguity, which is probably pretty hard. And we have a puzzle by Agent and Rax Zero, Shimadoku, which is a Little Killer variant mixed with a shimaguni. I'm probably pronouncing that completely incorrectly, and I don't care. Yeah, these all look a little bit scary, but uh, I've done this to myself. Looks like number 2 is leading. Oh, and number 3 is tied with it at 44%. Well, we're not doing both of them, so we have to break the tie. You're not going to loophole me here in doing 2 really hard puzzles. Oh, and welcome our newest patron, Sarah. Thank you. I just saw that on my phone while I was looking at it. Because you're allowed to look at your phone at work when it's streaming. Okay, so we have 10 votes out of the 12 viewers. And we're at 50% for 3, 40% for 2, 10% for 1. Going once, going twice, going 3 times. Sold to number 3. All right, so we're gonna do some shimaguni. Please tell me I'm pronouncing that incorrectly, because there's no way that that is actually how you're supposed to pronounce that. All right, let's bring up the puzzle here. Of course it's gonna do this to me again. Why wouldn't it? All right. Why is there a... I guess I just have to react. I mean, oh. Uh oh no, what have I done? I've ruined you, chat. There was a random heart next to a message, so then I clicked it and then it wanted me to sign in. Okay, let's see if this works. You back? You're back! Woohoo! All right. Enough issues aside. Normal Sudoku rules apply. Insert the digits 1 to 9 once in each row, column, or box. And box, not or box. Choices here. No choices here. Only facts. Shimaguni rules apply. Shade a single group of orthogonally connected cells in each dashed cage region. Shaded groups may not share a dashed border. Okay. So like if this was my shaded group in the 8 cage, then this cell couldn't be shaded in the 10x cage because it says shaded group may not share a dashed border. And no two adjacent regions may contain the same number of shaded cells. So if this, again, was my shaded in the 8, then this could not be my shaded in the 10x because that would mean that this region has an adjacent region with the same number of shaded cells. So that's not allowed. This would have to be like this, for example. Cage sums. Digits may repeat in cages. Some cages have one or more or two sums indicated. The first value given is the sum of all the digits in shaded cells, and if given, the second is the sum of all digits in unshaded cells. A cage sum x is to be determined by the solver and is the same value in all appearances. Okay, interesting. So if there's only one value given, that value must be the shaded, right? If I'm understanding correctly. So this is shaded, I think is what we're saying. So therefore, all these have to be unshaded, otherwise they would share a border that's dashed with this shaded region. And of course, this has to be a 6, therefore, because that's the sum of the shaded cells. So there can't be more than 3 shaded cells in here. Excuse me. But that's pretty much all we know. Shaded and unshaded sum to 7 in here. Interesting. Any other gimmies? I mean, this is a very, very large cage. 39 and 41. So that sums together to 80. 80 is a large number, I would say. 80 is not a number I'm used to dealing with in Sudoku. Of course, cages can repeat digits. And you can repeat digits in the... Right, you can repeat digits in the shaded cells, too. So, actually, I think this could be a 4 shaded region in reality, because if it was a 4 shaded region, then we could do 1, 1. Yeah, 1, 1, 2, 4, for example, would work. Okay, so what about this x value? These two cages are both basically 3 cells, but they both sum to x, and they can't have the same number of shaded cells. And this, they can't both, wait, actually, they can't both have 3 cells shaded, for obvious reasons, because they would have the same number of shaded cells, but also they can't have this border here. So either x is a single digit number, which it's not, because this has 1 shaded, so this actually has to have at least 2 shaded. So if this was shaded like, wait, so if it has to have at least 2 shaded, then that's shaded. Oh, x could still be a single digit number because it could be 1 shaded in this cell, for example, and that wouldn't conflict with this. Not necessarily. The Shima part is forced here? The left cage to be 2 shaded. Does it? Well, I know these are unshaded, and this has at least 2 shaded, so this is shaded. Okay, okay. This is what you're talking about. Okay. That makes more sense. Right, okay. We can unshade these. This can't have 1 unshaded, or 1 shaded because it sums to 17, but it also can't have 2 shaded because this has 2 shaded. So this has to have 3 shaded. This has to have 1 shaded because it sees this which has 2 shaded. So one of these 2 is shaded, and the other one sums to 7 and 3 cells, which is going to be 1, 2, and 4. Only way to make 7. So this is 1, 2, 4, and 7. Definitely a 7 in there. I guess we know that, obviously. So these are obviously all unshaded as well, which breaks up this one, which means that only one of these 2 cells can be shaded. And it can't have, wait, the shaded cells can't be separated anyways, so it couldn't have 2 shaded anyways. But this one now can't have 2 shaded, because if it did, then it would be next to this one. So this actually has 3 shaded, which means that all of these are unshaded as well. Yes, which microstudy said, but I ignored. So these are also unshaded. And now the shaded have to be at least 2 because of 15. So these sum to 15. Oh, 17 is obviously 8, 9. So we could probably do that. This is 15, which is at least 6, 9. This is X, so we can fill that in with, oh, I don't have the letter tool on, but I was just going to fill in an X. Oops. That joke did not work. But this is at least 3 cells, so this has to be 6, 7, 8, or 9. 6, 7, 8, or 9. Yeah. But it can't be 6 because of that. Hello, Carl. Welcome. We are doing a Shimadoku. 4 cells on. Oh, yes, we can unshade more cells. What is this cage? What the heck is going on there? Oh, this is just. Oh, okay. So this has 1 shaded. Interesting. Okay. Is that even useful? Oh, that will probably unshade some of these cells. Oh, actually, that's making me think about these 2. Because these have 1 shaded cell, right? But if that shaded cell, for example, is here, then all of these are unshaded. But I can't make 23 in 2 cells. So, in fact, this is the shaded cell here. That's nice. That is really nice. Actually, let me just go back for a second. I did something really fast. These 2 will be unshaded, and then the biggest group of congruent cells together will be these 2. This one doesn't have to be unshaded at that point, but yeah, it is. It would be in that case. But then this is a 7. This is not a 7, and this 23 could be 3 cells, but without a 7 or a 6. 8 plus 9 is 17, plus 6 is 23, so yeah, you definitely can't do it without a 7 or a 6, so you have to do 4 cells for sure. That's obviously going to be unshaded. Is that not what congruent means? I think it is. Consecutive, contiguous, sequential. That's a fun one to say, sequential. Really difficult to say, and like, I was going to say difficult to say in 1 syllable, but that's because it's not a 1-syllable word. It's difficult to say lots of 2-syllable or 3-syllable words in 1 syllable, obviously. This has 2 shadeds because congruent is the same shape and size. Congruent? Is that really what that means? That is not what I expected. I think mathematically you're correct. But I guess this is what I meant. Clearly, these would not be in harmony with each other. Hi, Kodak. Welcome. Oh, for some reason, my brain said if it was 3 cells, it would have to be these 3 cells. But I think it could be just these 3 cells. You're right. Because 6, 8, 9 would work. Yeah, I think it could be that. Yeah, I think you're right. Yeah, these three are for sure shaded. But this one we're not quite too sure about. Uh yeah, it couldn't be like this because then they wouldn't be congruent. Now I'm just gonna keep using that word. Um no, it doesn't mean that at all. Okay, so this needs at least one shaded cell in it. If that shaded cell is, say, here or even here, that's really cutting into this 39 total. Can we make 39 in these cells? That's going to be... We could have repeats, so probably. 8 plus 9 plus 8 plus 9 is already 34. Yeah, okay, that's definitely okay. So we can say the same thing about this. If this is shaded, then these are unshaded, and then we only have 2 cells to make 21. Again, I'm saying this would be unshaded because it wouldn't help to not shade it or to shade it. But the point being that this is unshaded and this has to be shaded. So this will be unshaded, and now we have to make the 21 in these 3 cells. The congruence would be ruined, of course. Good thing I wasn't spouting off congruence in Zeta stream, otherwise I might have been kicked off early. Just kidding, Zeta wouldn't do that. Even if I was spouting mathematical nonsense, I'm sure. Uh, anytime you strand a single cell next to a single shaded cell region, it's automatic. Oh, yeah. You meant with like this sort of thing. So this would be 5 cells now, which you could probably still do. I mean, 9 plus 9, 18, 18 plus like 18 plus 21. That's definitely 39 at least, right? Yeah. Is that exactly 31? 39? Sorry, 39? Yeah, it is. It is exactly. That seems like a weird coincidence. uh you can do something weird with the 8 cage in box 3 and the 10 cage below. Probably. Sorry, excuse me. So the 8 cage can no longer be 3 cells. It can no longer be 2 cells. So it's got to be 1 cell. Where that 1 cell is, I don't know. But there is an 8 in here. We know that. The 10 can't be 2 cells. And it can't be 3 cells. And it can't be 1 cell because 10 is not 1 cell. So it needs to be 4 cells. Which is pretty cool. And 4 cells which sum to 10 have to be 1, 2, 3, and 4. Yeah, I got there eventually. So then these are unshaded, which means that the 8 is pushed up, is less helpful, but it's okay. I can repeat digits. How annoying. So we can't do that. We could repeat this digit here, but that's the only digit we could repeat. So we could repeat double 1, and then we could have even a 5. 5 is the highest digit we can put in here, right? Like, if you put a 6 here, 6 plus 2 is already 8. Plus 2 is 10. How did I get 5? How did I get 5? Okay, so these have to be 6 or less, and these have to be 4 or less. If you double up 4, well, it doesn't really matter because you could just do 1, 2, 3, 4, and then these could be 4s. So, yeah, I think this is how we can label it up, right? 21 in 3 cells could be 6, 7, 8. Otherwise, it needs a 9 in it. Not too interesting. But this does mean that our x is a single digit, which we already knew from over here. It's in 7, 8, or 9. So we have 7, 8, or 9. Not in 2 cells. But it could be in 3 cells or 1 cell. As long as it's not this 1 cell. You always let Sven do the math for me. For you. Geometry is hard and arithmetic is hard. Yep. Okay, so let's think about this, because how many cells can this have? Well, if this is a 3-cell sum, that seems ridiculous, right? Because that would make these all green. Which we decided we could do if we did like a 9, 9 with 7, 6, 7, 8. Super annoying, but possible. I think we could do that. Ah, that is a cool step. How could x be 7? If x is 7, either this is a single cell, which cannot be 7, or it is a 3-cell, which cannot be 7, because it sees a 1, 2, 4. That's really cool. So this cannot be 7. J has a cool step. Oh, that's J's step. How did I think that was micro study? I don't know. I'm tripping. This is 11, which can be made with lots of things. Yeah, that was definitely J. I mean, this definitely has a 1 in it. Is that helpful? Nope. So X is 8 or 9. Don't see anything, really, with the X stuff. I think it has to be this 3941 debacle thing. Yeah, okay. Shade versus not shade. Uh, Top left cage has a borders a 3 cell shaded. Okay, yeah, you're right. So this has to be shaded, which I think tells us even less about what it could be, unfortunately. But oh, 30 in 4 cells, but you can repeat digits is a little bit interesting because we, I mean, this cell could be 7. That's the highest it could be. Okay, Clark, do you want to come up and see the stream? Fine. 39 and 4? I don't, that's going to be really hard. I mean, can't even do that, can you? You need 2 repeats to do 39 and 4? Yeah, you can't do that. Uh, so you'd have to do 39. In how many cells can we have over here, really? Because if this is only one shaded, it's like this is the maximum, right? Yeah, that's the maximum number of cells we can have over here shaded, which is 5, which is the same as the maximum number of cells we could have over here. So we do have 5 shaded in this region. Or we can't have 4 shaded. That's impossible. So we do have 5 shaded. It's either here or it's over here. But these are 5 shaded, 39 in 5 cells without repeats because it's within a box is just impossible. Because the max you can do is 35 in 5 cells. So these have to be the shaded ones. Which means we have to do the 9 and then repeat the 9 and then do a 6, 7, 8. Because that's the maximum and that's exactly 39. Which worked out a while ago and I was annoyed, but now I'm appreciative. So therefore x is 9. So that gives us less information about this again. This now can't be 39. Okay. That's enough. There's a 6 in here. There's a 9 in one of these two. And then the other 2 cells are a 7 and an 8. I guess we can just like center mark this. Why are we, what am I doing? There's a 6 over here. Oh, that limits this a little bit more because it can't be 3, 9 and it can't be 5, 6. So it's either 4, 7 or 3, 8. Which is of course the 3, or sorry, is of course the 7 or 8 that's down here. Which if it's 7, then that's a 7. Ugh. Hair in my nose. This has to sum to 9, which can't be 3, 4, 2 now, so it has to have a 1. It's either 3, 5 or 2, 6. 2, 6 being the 6 down there in the, oh, the 6 can't be in there at all, so it is 1, 3, 5. So this is 4, 7, which means that this, oh, whoopsie, that this is a 7 and a 7 up there. So then this is a 2. There's a really nice flow to it now. 30 in 4 cells, with repeats though. This is 1, 3, 5, and 4. Oh, this one? Yeah, yeah, I already worked that out ages ago. Um, 8's in here with something, maybe? No. Hmm. Villager noises. So these are all unshaded, right? Which means that these unshaded cells have to sum to 41, which seems insane. +23 plus 7. Carl says is 37, which therefore means that this cell is going to be a 8. An 8. It took absurdly long for some reason. So that's not an 8. It's green. So these two cells have to have a 6 in them, which means that this is a 6. Means that these are 3, 5, and 9, just to complete the box. Which means we can fill these in 8, 1, and 4. That's not a 1 or a 4, which is crazy because this can't be 6 now. Because that needed double 1. Could be 5 with double 2, 1, 5, right? 4 plus 6. Yeah, that's obviously 10. I don't know why I counted it. I just knew it was true. Uh, oh, the 9. The 9 is just placed here, isn't it? Yeah, the 9 is just there. In this one, we need to make 9 in 2 ways. So, well, these. Oh, okay. This is just 4 or 5 because it sees all these and a 6. So then this is. Well, this can only be 6 or a low digit. 7 in box 3. Oh, nice. Okay, 7 in box 3 is done. So this is 6, 2, 3, and 5. Fortunately, that's not fixed yet. Let's see here. So it could be 6, 3, or it could be 3, 6, or can't be 4, 5, obviously. It could be 7, 2, or 8, 1. I don't know why I was saying 8, 3. 8, 1. The 5 here, does that help us all? There's a 5 in here, super not helpful. Obviously, we can get rid of these 4 pencil marks because we know the 4 is in here now. You can J40 point that on 21 box 9. Oh, there's a 9 in the box. Yeah. That's a 7, 8, 9, and we know where the 7 is. Now the 6 is pretty restricted in here. Just from the fact that we can't put the 6 in the 10x cage anymore. Right, there's 2 7s in here, which means that the 7 in this box is up here, which means that this can't be a 7 and this can't be a 2. Little Joey wing there. Thank you, Doom Dion. Carl thinks, sorry, Carl thinks row 4, column 1 and row 4, column 3 have to be a 7, 9 pair. Well, 9 is definitely up here. Why can't 9 be there? If this was a 3-cell 9 sum, the 30 sum in box. Okay, so if the 9 was here, 7, 8, 9 would need this to be a 6 to make it to 30. So that does not work, right? So that can't be a 9. So this needs to be a 7, 9 pair. Cute. So this is either a 6 or it's two more. Sorry, 2 more. So that would be an 8. So it's either 7, 8, 7, 8, or 9, 6, 8, 7. Yeah, I guess we're still avoiding the big cage. I mean, we can come back to it. I mean, these are 1, 2, 3, obviously. So that's 6. Then what's the minimum we can... I guess the minimum here is 6 too, right? So if we do 6 plus 6, then what would this be? Oh, there's also this cell. Okay, wait. Let's go back for a second. Let's do things we know. I guess this cell can't be very big, huh? That's a 9. That sees a 6, 8 pair. So that is a 9. So there is a 9 up here. And I'm still trying to... Oh, there's also a 7 up there. That can't be a 7. So the only spot that the 9 could go in would be here, if this is a 1 cell. If this is a 3-cell sum, does that make this too big? Because that would put 7, 9, and 8 in here. God, this is so much addition. Really making my chin scratchy. Or itchy. Scratchy. Itchy is such a weird word. I feel like I've said this before on stream, but itchy is such a weird word because you itch and itch. Like it's just stupid. Anyways. 7, 8, 7, 8, 9, and not necessarily the 6. So let's see, 7, 8, 9 in here would be... I don't even know what that was. There was a noise, and I don't know what it was. I think it was Clark, but... Right, you said you scratch and itch, but if you itch a scratch, that's bad. Because you're not supposed to itch a scratch. You can scratch an itch, but you can't itch a scratch because it might get affected. Such double standards here. Sorry, I'm really putting off the summing of this big cage. 7 cells min 28. Okay, yeah, I agree. 28 plus plus the 6 is 34. 34 plus another 6 is going to be 40. 41. That's minimized. Okay, so we can actually just say that it is minimized. Perfect. Which means that this is 8, 9, which means we have a 9 here and an 8 here, which means that this is shaded and these two are unshaded. Excellent. All right. That means that there's no 1 here, which means that there is no 1 here. Except for me, of course. Always love that joke when Simon says it. Uh, okay, so we can get all this from this wonderful big cage deduction. Ah, scratch is really itching. 3, 8, and 4. No, not 3, 8, and 4. 4, 8, and 5. This is not a 3. This is an 8. That's a 1. 7 and 8. 7 and 4. 8 goes in. That's a 4. That's a 5. That's a 4. 7 plus 4 is 11. So that's going to be a 6, which we knew from the box anyway. This is a 4 now. This is a 3. This is a 5. This is a 9. That's a 4 now. Jeez, I even put coconut oil in my hair this weekend, and apparently it did not help. Super dry here. Really warm though. Okay, so that's a 2, that's a 1. Even in Canada, weather is awesome. Thanks, global warming. The 2, these are not 2s. Said itch too many times. It doesn't sound like a real word anymore. That's for sure. There's no 5s in here anymore because you can't double up the 2. That's not a 2. These are not 3s. That's not a 4. These 2 need to be 4 and something. 1? Well, that's helpful because that's fixed. 1 and 4 and 2 go in. Now I'm stumped for some reason. This is unshaded. I guess we can fill in 2, 2, 3, 5, 6 and see what happens. 2 and 6 are out from here. These two. That gives us a 3, 5 pair, weirdly. So that means this is 1, 4, 2, 3. So this 10 gauge now works. Oh, yeah, that's true. 6 in row 6. 6 in row 6. We already know that. Oh, 6 in row 6 marries up with this, which gives us this. Okay, yeah. So this is 6, 2, 3, and 5, but not 5, so that is 5. So that's a 3. So that's a 3. So that's a 2, so that's a 3, so that's a 2. That's a 5. That's 5, that's a 1, that's 1, that's 2, that's a 3, 2, 5. I'm just trying to confuse it now. 3, 6s and 8s go in. 8s and 1s go in. Hey, Rocky. How's it going? It means that we're solving both no solutions puzzles, puzzles without solutions, and also puzzles with solutions. Which this one, I hope, has a solution because we're almost done. This is a 5. What's this? This is a 6 and a 3. And now we need to place 5 here, 5, 4, 4, and 2. Woohoo! That was a really fun puzzle. I enjoyed that quite a bit, except for some reason the 41, I just really did not want to do it. But Carl convinced me to do it. Another palindrome time. Have we had palindrome times? Oh yeah, we totally did. This is 3113, and this is 4004. Row 6 column. Yeah, I think you might be a little behind Sarah. Yeah, it was great, Rock Rat. I would love to do that, Panthera, but I don't know if I have the energy to do it today. I think I'm gonna do 3 more no solutions, and then I think we're gonna be wrapping up for the day. But another time, perhaps, you should put it in the submissions, because then I will be reminded. Welcome back, Nell. We're moving on to no solutions. Entropic Killer by Doomdiat. So we prove that this has no solutions. Again, it's entropic lines, so 1 low digit, 1 high digit, and 1 medium digit in every 3 cells. And we have a 15 cage, which, as the chat is saying, I already know, is entropic in nature. So if I put a 1 in a 15 cage, for example, the other 2 cells have to sum to 10. No, not 10. 14. One of which has to be a medium digit, like a 5. And then the other one has to be a high digit, like a 9. Or it could be 6 and 8, but that's going to be 1 low, 1 medium, 1 high, just like entropic. You can submit a real puzzle to puzzle submissions on my Discord channel, and a no solutions puzzle to no solutions. Or 3 mid, right? Or 3 mid. So 4, 5, and 6 would also work, of course. A real puzzle, yes. Yes, you're very upset with me. Okay, so we have 4, 5, and 6 for the other thing, and I'm pretty sure we can't do 4, 5, and 6. Let's just color this entropic line. I don't really... Oh, what's happening now? Why do they have little borders on them now? I feel like I did something, but it didn't do anything, so I think I'm fine. Right, so this cannot be 4, 5, 6 because these are not all the same color. And this also cannot be 1 low and 1 high and 1 medium because there's 2 grains. So for example, if I made these both high, that's already more than 15. That's 7 plus 8 is already 15, plus this digit will be too much. If these are both low, 2 plus 3 is 5, which would mean this has to be a 10. If these are both medium, then this also has to be medium, which again does not work. So we have proved that to have no solutions, and we can move on. Nice little puzzle there. Parallel, I hope I'm pronouncing that correctly. That's how I always pronounce it in my head. Is the author of this no solutions between line puzzle. And between lines are essentially that this digit has to be between these two, strictly between. So this could be higher, but this couldn't be like a 7 or an 8 because that's not between 1 and 5. And we can't do 1 and 1 because that wouldn't be between 1 and 2. It would be equal to 1. Parallel. Yeah. Okay, so obviously the one thing we should know about between lines is that we can't put a 1 or a 9 on them because you can't put anything on their ends then. So these are going to have to be 1s and 9s, and we have a deadly pattern, and therefore there are multiple solutions, but that's not what we're proving. Under spoon. Okay, so we have these 1/9s, but we can only put 1 or 9, or two 1s and 9s in these cells, of course. And no 1s or 9s here. So we're gonna have to put 2s and 8s in these cells in both boxes, but We're gonna have to be careful about it, I guess. Trying to think why this wouldn't have a solution. I mean, it seems way too pretty to be true, but hello, Malrog. Oh, it's an S cell on 1-9 in box 5. Duh. I literally said all the parts to it, but I didn't even realize what I meant. So there's a 2 and there's an 8 in these two boxes, right? The 2, wherever it goes, let's just say it goes there, will have to have a 1 on one of its ends. So there will be a 1 in one of these two cells, if this is the 2. The 8, let's just say it's there, will have to have a 9 on the end, because you need a digit outside of 8, and you need a digit outside of 2. The same will be true down here. So if we put the 8 over here, then we need a 9 in one of these two cells. And if we put the 2, say, there, then we need a 1 in one of these two cells. But then the 1 and 9 are taken in rows 4 and 6. And they're also taken in columns 4 and 6. So this digit has to be both a 1 and a 9. S cell on 1-9. That's awesome. This would be a really cool break-in, yeah, if you modify it a little bit. Feels similar to something I've done before, but not exactly the same. Or maybe something I've tried to do before. Can't remember if this is a real puzzle that I made or just something that I thought about. Anyways, I'm sure many people have thought about this. This isn't like me saying that I made some miraculous thing. You can make the same thing as someone else, obviously. Anyways, that's a pretty cool puzzle. I like that. And we reach our final and probably scariest no solutions puzzle of the day, which is not a Sudoku. It's a Japanese sums, like just regular Japanese sums, no Sudoku attached, no Latin square attached, by K&T. And apparently this has no solutions. So we have to use the digits 1 to 6, but we don't have to have 1 to 6 in every row column. And there's no boxes. But we can't repeat the digits in each row and column. And we have to have a space between each set of sums. So for example, this 6 could be a 6, a 2-4, and a 1-5. Separated each by one cell. Or it could be 1-5 like that, separated by 2 cells if we want. But we just need to find a valid way to fill, well, a not valid way to fill these clues. And I'm guessing because of there's only one clue in each of these. I'm guessing not clued cells, like that doesn't mean there's nothing in here. That doesn't mean that there's an implied 0. It just means that we didn't tell you about that. But the 21 by itself, without any question marks with it, I think does indicate that there's only one run of cells, which adds to 21. And of course, 21 is the digits 1 to 6 summed together. It's not a Latin square, because you don't need to have the digits 1 to 6 in every row and column. You don't need them. You can have 1, 2, 3, and then nothing. So, but the 21 will have to have 6 consecutive cells, 1 to 6, because we can't repeat digits. So, how are we going to do this? How are we going to prove this is not true? Huh. So the 6 obviously has to be some variation of what I said. Something like this, but just permutated or, rotated. What about the 4, 5, 6? I guess that could just be a 4, a 5, and a 6. Or it could be a 1, 3, a 5, and a 2, 4. What the heck is this? Oh, I guess could the 6 be 1, 2, 3? No, it can't because then we can't make the 3 6s, right? But could this 6 be 1, 2, 3? Yes, it could be because it could be 5 and 4, right? Okay. One end of the 21 has to be empty, is what J40 says. I'm not sure I really follow. Why? Why can't we just have like 6, 1, 2, 3, 4, 5? And then like a 6, like a 2, 4, 1, 5. Then, oh, okay, I see what you're saying. Okay, I didn't understand what you're saying. So either what he's saying is either this cell or this cell is empty because we can't touch both of them. And the same is true for the nines, right? Either this cell or this cell is empty. Which I guess has some implications for the sixes. I mean, right, so the sixes need to be two. We need two cell sums for them. At least two of them. So at least two of them need to take the first cell. So then we need to do that on both sides, right? Or like the nines and the 21s, like it could be like this, for example. Yeah, okay. Which would make this all in, this all in, at least that in, at least that in. And then you'd have to ask, like, oh, now this is broken. Because I can't take these cells, and I can't make these separate. Wait a second, wait a second, wait a second. You don't have much. Okay, wait, let's go back here. Let's go back here. We don't have much wiggle room with the 21, right? So we need to always take. We always take these cells with the 21. Right, this is the point. This is the point. We always take these cells with the 21. But this makes this really hard. Because hey, Benny, you're really going up on the wall right now. He's trying to climb the wall. Don't know why he does that. Because if I tried, well, first of all, let's cover the obvious. I can't make any of these 4 cells new sums, right? If I include this cell as a sum, it's going to be with this, because I need to have at least one empty cell between them. So the best I can do is take, I need to take one of these cells for one of these sums, like the 5, for example, right? I can't, there's no other place to take another sum, another set of cells. So one of the 9s has a cell in here, right? One of these cells has to be a part of the 9. But it doesn't work, because if the 9 has one of these cells, we know that every single one of these 21 and 9 clues has to touch the edge because of these 6 clues and how the 2-cell sums work. You have to fit two cell sums into the columns. And we can only do that. Like you can't not. Yeah, it's really hard to explain it, but essentially that would mean that this would have to work. And 4 cells cannot add up to 9. Holy crap, that's really hard. That is so hard. This is a really interesting puzzle. Like if this was just a 10 clue, that's already really cool. It can't even be a 10 clue. Even if this was a 10 clue, it would still be broken. Oh, no, because it could be... No, it would still be broken. That's weird. Because you can't go up to make the 5, and you can't put a 5 here if this was a 10 clue. That's really cool. Okay. Yeah, it's a reachability argument in the end. Like you can't reach this with the 9 because every clue on the side has to touch the edge because of the 2-cell 6 clues. That you need 2-cell 6 clues. Yeah, tongue twisters. You need 2 6-cell. You need 2 2-cell 6 clues, and those need to touch the edge, and they need to take 1 cell from one of these 4 rows. So yeah, then it can't reach. Okay. Whack. All right. I wouldn't hatch this idea. I mean, I don't know if I can do a tongue twister stream. That's a little bit too challenging for me. This is already challenging enough. Just saying 2 cells, 6 clues. How is that challenging to say? How is that challenging to say? Anyways. Yeah. Well, I'm tempted to just like turn off the stream. Just at that. But yeah, thanks everyone for coming out and watching. I think that's where we're gonna end it. But yeah, again, thank you to Sarah and Directionary for supporting the channel. You can support the channel down below, and of course, subscribe if you haven't subscribed. Like the video if you have not done that. Yeah, have a good night, everyone. Thanks for hanging out. I love streaming and love talking with you wonderful people. All right. And come this weekend for Playmaker's interview on Sunday, I want to say. Yes, Sunday. All right. Bye, everyone.